Hello everyone. Welcome to our first ever Game Development Day online event.
The first online event by ID developers for game developers.
Well, yes, welcome. So let's see how it goes. By the end of the day, we'll learn if we managed to accomplish the mission. So my name is Anastasia. I'm the marketing lead at JetBrains. And my first game console was Kenga, where I played DuckTales, Mermaid, and, kind of Barbie game. So this is my co-host, Alex.
Hello, folks. My name is Alexander, and I am a product manager / developer at JetBrains on the Rider project, mostly working with the Unreal integration. And my first game console was Dandy, a bootleg version of the Nintendo Entertainment System that was mostly sold in Russia. And the first game, I think, was some cartridge with 100 bootleg versions of Contra or Mario or something.
Yeah, sounds cool. Many kids actually dream about becoming a game developer and creating the coolest game ever in their life. And we can maybe ask our audience what was the first game they created. So feel free to comment on YouTube or Twitch in the comments. We'll read them later. And I could say that I actually started something like game development when I was a kid, and with a game similar to a snake game. It was, if I remember correctly, written in Pascal. Sorry for that. Terminal-based game, and that was actually fun. It was awful, but that was fun. Later, I learned C++ from my mom, who was a programming teacher. My life has changed completely. Somehow, I never did games after that, so only boring stuff like telecom and microcontrollers. So, Alex, what about you?
If you go GameDev, you go full throttle. So my first game was FIFA 14. And the funny thing, like it was my first big commercial project that I was working on. And the funny thing that apart from many of my colleagues and other developers who were dreaming about making games when they were children, and then eventually they become like telecommunication, banking system, and such developers, I was pretty happy just playing games and not making one. And I was an FPGA engineer and who got just, I don't know, by sheer luck in the game dev community. And ever since I've loved it.
Oh, cool. Actually, we have lots of cool answers from our audience. So some people write that they did the first calculator game, and they're sharing their first consoles like Atari, and some others very cool answers. Actually, I haven't seen many of these consoles, I would say. So they're mentioning Commodore 64, I guess, MSX Basics. Oh, that's cool. I don't know, Alex, what do you think about these answers? I think we have a cool audience here today. Welcome, everyone.
Yeah, for sure. And I feel for Almamu who got the Mega Drive first, because even though it wasn't my first console, it was like the most favorite mine when I was a kid. The Mortal Kombat was just stick to my heart.
Yeah. Okay. So I think we need to stick to our program. And I would like to share a little bit insights of our cool program. So today we'll have 5 awesome talks about game development aspects. So we'll start with the 5 game developer habits that help software engineers reach the next level by Alex and Erik. Then we'll go to the discussion about the plugins and making plugins for game engines as a business. There will be a discussion between Alex and Victor. Then we'll come to Tom Looman and we'll discuss profiling and game optimization on a budget. And the next talk will be about Unity packagers. So if you're with Unity, you have to learn that definitely from Felix. And we'll end the day with the UI topic and making UI with C++ in Unreal Engine with Ben UI. So that's our plan for today. Yeah, I think we'll ask our speakers definitely what were their first games, definitely. So wait for that. Also, I would like to say that during the breaks, we have a few breaks. We'll have some fun raffles. And the idea will be very simple. We'll be asking some game-related questions, and you'll have to answer first, and you'll win a cool prize. So we'll be raffling our .ultimate licenses. Wow, I guess that's huge. So stay with us during the breaks. You can grab a cup of coffee, but you can miss the raffle. Sorry for that. And the recording will be available after the event. So you'll find this link on YouTube stay in live, and you can rewatch any content you would like, and then we'll cut individual topics into separate videos. Okay, and I would like to invite our first speakers to kick off the day. So Alex and Erik, please join us. Welcome.
Hello. Hello.
Yeah, hello. This presentation is going to be very unusual, actually, because Alex and Erik developed a game to present to you. So who could imagine that for a game development conference? Yep. Okay. So, but my first question.
It's the subject, right?
Yeah, my first question would be like, what was the first game you created?
Well, I created. It was during my studies, and I did a little mashup between a rhythm game and Angry Birds, where you had to basically defend your castle on the beat of the music. So yeah, it was pretty interesting. It didn't really work out in the end, though.
No? Mine is a bit longer ago. It was I heard from the audience as well, a C64. I'm from that age, so I developed in BASIC a maze game that worked pretty okay, but yeah, after a few levels it kind of crashed. But yeah, that was the first experience I had with game development.
Sounds cool. Okay, so let's start the presentation. So the stage is yours, and I guess you can start.
Thank you.
All right.
Okay, let's grab our controller.
Yeah, because you give the presentation with controllers nowadays, right?
Indeed.
So we're going to talk about 5 game developer habits that bring software engineers to the next level, right?
Right. Yeah.
So yeah, who are we? Let's start with that. For starters, my name is Chatzizacharias. I'm half Greek, half Dutch. We're streaming from Utrecht to the Netherlands, by the way. Thank you. With a beautiful mustache that I do not have. And I studied games. I worked in some small mobile game developers. I did a lot of indie game projects, and at some point I decided, oh, let's give software engineering a try, and then transitioned to full-on .NET developer, and now even a Java developer. And that is me.
Brings us to me, myself, and I. Next one, yeah. I'm Erik Pronk. Not my background is not in IT. I've studied food technology. That's kind of different, but during that period, I switched to IT. That was around the millennium. So they had a lot of need for IT personnel, and yeah, that sounded like a fun thing to do. So I did that. Now I'm working at JetBrains as a software engineer architect, and yeah, I love what I do, and I love to combine my passion for gaming and technology with it.
As you might have understood, I will be the game developer
Yes.
of the talk, and you're gonna be the software engineer.
I will be the software engineer.
Right? Okay, so this is where we'll be having our little adventure.
Yeah.
So yeah, I think we can go to our little ghost guide, the guide, maybe.
Yeah, our guide. He's going to guide us through to what we're going to do today here.
And a good starting point is, as he's pointing out, is why do we want to give this talk?
Why do we want to give this talk?
So yeah, I mean, game development and software engineering are very related, right? They are very similar, but there are some key differences, that habits, methodologies, you could say, that differentiate the two. And as having worked in game development and software engineering myself, there are some things that I really like about game development that are not necessarily happening a lot within software engineering. And well, vice versa.
Vice versa, yeah. We're gonna have two views on the subject, and yeah, we'll go from there. And I think we can have a nice conversation on what we can learn from game development and the other way around.
Yeah.
So let's go in.
Let's get started, right?
Yes. Let's move down the hallway.
The dungeon.
Yeah, the dungeon. We don't have an agenda. We have a walkthrough, of course, because this is a game.
A game fact.
A game fact. So we're going to do a stroll down the hallway of history around software development, but software engineering, but also on game development.
Really to highlight the differences and the similarities.
Yeah, the differences, similarities, and some highlights of the eras. And I'm going to play 5 mini games with you guys. The first one is on performance, a very important subject in both sides of the coin. Then we're going to talk about agility. What is agility, and what does agility mean for a game developer, and what does agility mean for a software engineer? Same about full stack. How do we look at full stack, and what is full stack for a game developer or for a software engineer? Then we're going to focus on requirements and what a puzzle it can be. Then we're going to play the fifth mini game, which is going to be a lot of fun.
More fun than that guy, hopefully.
Hopefully more fun than that guy, indeed. And we're going to close it out with a conclusion. But first, we're going to start at our history waterfall, right?
Yeah, our trip down memory lane. I mean, if you look at this talk and in the end you're like, okay, I don't agree with this, that's fine. But at least we have given you a couple of history pointers along the way, right?
At least you learned something. So, so let's move down the hallway. And of course, I will start from a software engineering perspective because software engineering is somewhat older than game development. And for software engineering, the basis is in 1703 with a German mathematician, Gottfried Wilhelm Leibniz, who introduces the binary system. And that's the basis of what we're doing in software engineering, but also in game development, of course. A long leap to the future, but a thing that is very influential within software engineering is the invention of the Turing machine, which is actually a machine that is a decision box, and it's called the human in the machine, and it actually could solve all complex problems that are out there, and I think it still can. Great invention by Alan Turing, and influential on our within our software engineering perspective. Then moving on to programming languages. The first programming languages was Fortran. It's a mother of all languages, and it was introduced in 1957. It was widely used then. It's still used, but not as widely as.
If somebody still uses Fortran, feel free to throw it in the chat.
Yeah, indeed. We love to hear.
And 1 year later, the first game was created, which was by physicist William Higginbottom, which is also interesting. He also worked on the atomic bomb, so that is something I didn't know before.
Yeah, but it's not on the screen, right? It's a oscilloscope, right?
Yeah, exactly. And he made Pong, and every game developer knows Pong. I think almost every game developer at some point tried to recreate Pong himself.
Yeah, it brings us to 1968, where the start of the internet is, which was DARPA, who created ARPANET. That was the furthest connection of networks over America, the globe within America. So it's the birth of the internet, which will be hugely influential further in time.
Yeah, and then 2 years later, Computer Space was released, and it was the first arcade game ever. Maybe somebody played it at the arcade back then in the audience. I didn't. Maybe you did.
No, even before my time.
Okay.
Even before my time.
But it was really the first arcade game you could play commercially, which is pretty cool.
Yeah, that's great. And in 1971, the first personal computer was sold, the Kenbach 1. It was sold in the United States. It was the first personal computer out there. Then in the days it would have cost $750, which would be like $4,500 now. So still the same price as a medium-priced MacBook nowadays.
Yeah, and with the rise of personal computers or personal consoles and stuff like that, then Pong was also released as an arcade game that people could play at home. And maybe people that watch the 70s show recognize this console because it is what they actually use there as well. And they broke and Kels had to fix it. It was a pretty cool episode. And then in 1978, Space Invaders is the first game to sell over 1 million copies.
Yeah, everybody knows Space Invaders, right?
Yeah, and it made the game industry a multi-million dollar industry, you could say.
It kind of lifted off games.
Well, yeah.
Moving on to 1979, the Seattle University began offering a master's degree. So we finally could have got our degree in computer engineering, and that started. The first one was in 1979. So if there are any people out there who actually have a master's degree in computer engineering from Seattle University from 1979, huge kudos.
And what you see now is while the software engineering world, where was offering master's degrees and things like that, becoming more and more mature, the game industry crashed.
Yeah.
And everybody knows, or a lot of people know about the industry crash in 1983, right? Where Atari had to throw ET game cartridges in a ditch and dig them because there were just way too many. Pretty cool documentaries.
It was a great documentary.
Yeah. And then a couple of years later, Nintendo decided, okay, let's make a console. Let's fix this issue, this crash. And 8-bit consoles are born with, Famicom in Japan or the Nintendo in the West.
Yeah. Also, 1985, hugely influential also on the game development, but from a software engineering perspective, C++ was created by the Danish scientist Bjørn Stoop. But also, Windows version 1.0 was released. So 1985, quite an influential year for software.
We still use C++, right? Especially in Unreal Engine.
Absolutely.
And in 87, quick leap to the 16-bit consoles with the Super Famicom or the Sega Drive, Sega Mega Drive. There we go. The Super Nintendo, things like that.
Yeah. For my part of the whole way, the World Wide Web was introduced by Tim Berners-Lee. And also HTTP and HTML were introduced and thrown into the world and are still hugely influential on the part of online software, but also online gaming, of course. And moving on 1991, Linux was created by Linus Torvald, still very widely used as backend servers for games or for software out there.
Yeah. And then in 1992, Virtua Race and Virtua Fighter were the first polygon-based games. So truly revolutionizing how game developers make games, basically, from sprite-based orthographic layering of sprites to truly 3D. And actually, Virtua Fighter is the first game I've ever played as well.
Okay.
Which is not what you see.
I know, not this one.
Not this one. And then 93, Doom.
Yeah. I remember
but Doom was also kind of influential because it wasn't as known back then, but when they released the source code, we became quite know how much effect it had on the game industry with clever algorithms like the fast inverse square root and things like that.
Yeah, that's hugely influential.
Yeah.
1995 is from my perspective a really cool year because the introduction of Java on May 23rd, 1995, the first release of Java was done. Also Ruby and JavaScript were released in that year. So from software engineering perspective, software development, really cool period because the birth of Java has a huge influence on software out there.
Even though .NET and Java don't necessarily are the best buddies, you can't deny that they
have similarities.
And .NET was influenced by Java for sure.
Yeah,
and it really brought programming to the masses almost. You could say,
yeah. True.
Then in 1998, the Unreal Engine was created. We have some cool talks about that later, but it really revolutionized how the game industry thought about game engines because until this point it was okay, game has game engine, then you can use this game engine maybe for a sequel, and that was it. And Unreal was really the first engine that actually licensed the engine away for use by other games.
Yeah, and it's hugely influential for us as well because creating this game from scratch with everything that we did.
It is made in Unity though.
It's the same principle.
Yes. And then late 90s, a lot of people might have a lot of nostalgia about this. Is where online LAN multiplayer really became popularized.
Yeah, I know.
StarCraft, Unreal Tournament, Quake, Half-Life.
Unreal Tournament, a lot.
LAN parties, going to your friends, staying up all night, just playing games. Lovely
your
times.
friends with a car full of hardware
exactly.
to play a LAN party. Yeah, great times. Brings us to the early 2000s. In 2001, the Agile Manifesto for software development was published and Scrum was born. So at the beginning of the whole way with a waterfall, but now we're more in an agile way of developing software. And in 2001 was the first release of the software Agile Manifesto.
Yeah.
Yes, brings me to the next one, the rise of big data. Big data became a thing, became something that we know, still know, and is playing a real big part in everything we do from a software perspective, day in, day out. So it's really influential.
Yeah, and the beginning of 2000s, we also had the current console wars that are still ongoing, kick off. Nintendo, PlayStation were already, fighting for market share, and that is also when the Xbox was released, or when Microsoft decided that okay, I want a little piece of this pie. I want to get into the game industry with quite a lot of success, you could say. And then in late 2000s, mobile games start taking over the world thanks to iOS and Android. And I mean, by now, everybody, a lot of people know that, of course, mobile gaming is the biggest gaming market out there.
The biggest market out there. Yeah. Speaking of markets, also in the late 2000s and 10s, cloud computing begins to rise, but also the first Bitcoin transaction. I don't know if you remember it, but it was a transaction for a pizza for 10K in Bitcoin, which was actually $25 back in that day, but would have been 90 million today, or maybe 20 million in an hour, or 130 million within a.
It's a volatile coin.
So that's hugely influential.
Yeah, and you see it, of course, how it's splashed over to game development, because now there are so many NFT and crypto and blockchain games out there. And the metaverse, don't forget about the metaverse, which all started in 2012, where Oculus Rift kick-started, and VR was brought to the consumer. And right now, the people are trying to commercialize VR and bring it truly to everybody, especially Meta.
From my side of the hallway, but also hugely influential, I think, within the gaming development, containerization. Docker was released in 2013 to the world of software engineering, and shortly after Kubernetes, in 2014 was released. But also the term microservices was defined by ThoughtWorks. Kubernetes was, of course, highly long ago used within Google, but from 2014 it was open sourced.
Yeah, and when it comes to microservices, I tried to find out, was it the game industry that did it first, or was the software industry that did it first? I couldn't really pinpoint it, but I believe that the microservice architecture kind of started within the game industry. But I might be biased.
Yeah, you're biased.
But having microservices and the rise to software as a service also brought the rise to games as a service. And people know this term by now. Every other game, every big AAA title tries to be a game as a service, where they offer a subscription or offer microtransactions and create a stable revenue stream.
Yeah, brings us to the last one for both of us on quantum computing. 2016, IBM makes quantum computer available into the cloud, but also what we're looking at within software engineering right now and into the future. I think quantum computer is really going to make an impact on maximizing the things that we can do with our software capacity.
Yeah, and I can't wait to see what happens in the game industry with quantum computing. We have more raw power to draw from, because in the end, games always push the limits of the hardware.
Absolutely,
right?
Absolutely, as we see right now.
And that brings us indeed to the first point.
Yeah.
Okay, so this is our little hole. I think we can go to our first point, first habit we have, which is the performance first mindset.
Let's start with this mini game. So let's go to our guide.
The guide.
Yeah, it's a great guide.
All right. So, software engineers, do you think they think about performance all the time?
They do think about performance, but do I think it's always top of our mind? No, because we tend to focus more on clean code and code principles. And we have libraries for example, Link, and we do not take into account that there might be another way to approach it when looking from a performance perspective.
Yeah. So the games I worked at. I heard the term allocation budget or polygon budget a lot of times, and I think that's something that resonates with people in the chat. But in the software projects I work for, I've never heard the term, you have an allocation budget, you have a memory budget, things like that.
No, we don't.
And as game developer, I've really learned to always think what every single line of code I'm writing does underwater and what the impact is. Is this on the hot path? Is this not on the hot path? Can I get away with this? Things like that. So to visualize that, we made a little mini game.
And we made it proof for less gamer than
we made it casual proof, so to say.
Now, what are we trying to visualize with this?
Yeah, so this is a Squid Game for the people that watch the game, the show. Sorry, and there are good, there are glass platforms which can break and which doesn't break. And if you look very closely, you can see exactly which is which.
And it's also with performance. If you look very closely and take every line into account, you can predict the performance upfront instead of checking it from
later.
Okay.
On. So I'd say let's go to the other side. Let's hope we do. I do better than previous times because
I hope you do better than me.
Yeah, I hope so as well because I've been failing quite spectacularly.
Yeah, that's good.
Let's go.
I tend to make the jumps, but as we see here, I'm not.
All right, and then like this, I think, and then like this, maybe, like this, like this, like this, like this. Okay, and
not bad from my side.
And this should be the end.
It is the end.
I've seen worse.
Okay.
Oh, let's see the results. Now I pray I actually did better.
Yeah, and what we're going to see? You see that.
I did a little bit better from the looks of it. Not much better.
Not much better.
Yeah. Not even good at my own game. Kind of sucks. The pain of a game developer when players start beating.
I'm playing you.
Yeah, right, exactly. But this should give the idea that game developers really think about every single line they do because they always want that 60 frames per second, right? Or 30 frames per second when you really have to, when you work with less powerful hardware. And software engineers, typically they just write the right code. And at some point, stores are going to be pop up like, okay, fixed performance or outside consultancy is going to be brought in to look at the performance profile, everything, and see, okay, this is where you can fix things, right?
Yeah, that's true. But also looking from the game perspective, if you lack a frame, it shows immediately.
Gamers are complainers.
Gamers also are complainers, but because they have high standards and they're used to having a seamless experience. But from a software engineering perspective, a transaction takes a microsecond longer. That's not that big a deal. It becomes a deal when a lot of transactions start falling behind and your database isn't consistent anymore. So those issues pop up later, and then indeed you get the stories where, okay, our performance is lacking, so we need to profile it and we need to look at it. But I think what from a software engineering perspective we can learn if we make certain decisions that we need to do it from a perspective as looking at more at what the code could benefit from performance side, and not only from looking at how the code is written for maintainability or for cleanness in code. So that's something that we can learn from.
And of course, always a trade-off. But from my experience, I've experienced that when you really think about every single line that you write and what the performance is of that line that you're writing, at some point you're gonna have performance bottlenecks. And when people ask, okay, how can we fix the performance? Because you already kind of thought about it, you can immediately go like, okay, this is there, the issue is there, this is how we can fix it.
Yeah, true, and we need profiling to do that.
Yes. Okay, let's go to the next one.
Yes.
To the portal.
Let's see if we can get back to the hallway. Yes, we can.
And now we're gonna be
agile. Yeah, let's be agile. See if I can make this jump. Yes, I can.
All right. So I think 90% of all software and game projects
everything is agile, right?
Is agile.
Yeah. Yeah, we saw in the hallway. It's a very ancient process.
And Scrum is probably the most. If you use Scrum, just let us know in the chat. It would be pretty awesome. And or if you use Kanban, is also a pretty popular one. But what does agility mean? What is agility for a software engineer?
Agility in software engineering is that you have your requirements. You together with the team, you define what you're going to do within a sprint. You try to minimize risks there. You try to be as predictable as possible to get the value for money. Let's put it like that. You want to be predictable, and you want to. The customer wants certain features in a certain time frame, and you want to deliver that. So we have a process and methodologies in place to guide you through that.
It also sounds a little bit waterfallish, what you're telling me right now.
Yeah, no. That isn't true.
Okay, so we have a game development sprint and we have a software engineering sprint. And what you typically see, or at least what our experience is, also because software engineering is just more mature, right?
We have more years under our belt. So what you see in these two hallways is that are both sides of the hallways there are obstacles. But from a software perspective, the obstacles are more mitigated. There are well-defined stories. They are more predictable. You know where to go. You know what process to follow. You tend not to be. You don't want to be surprised.
Yeah, and in game development sprints, or at least the sprints I worked with in games, if you have the following experience, let us know. You start working on a feature in a game, and then game designers have this crazy idea, and they come to you and say, "Okay, we're not going to do this anymore. We're going to do this instead." And then suddenly you have to stop everything you were doing, stop on your tracks, and just do something else.
Yeah, and that's from a software engineering perspective, that's not the way you want to work, because you want to be predictable. You want to, that was a hot one. You want to know what you're going to deliver. So you want to work on the things that are the highest priority and provide the highest value.
Yeah, and it's almost like something sacred, the sprint within software engineering.
Yeah, it actually is. Yeah, it's a holy ritual.
Yeah, I've experienced a lot of times that people say, "Okay, no, we cannot do this today, or we cannot fix this bug today because
it's not in the
sprint. Yeah, we cannot change the scope of the sprint."
Yeah, and I think that's one thing that we want to address with this talk is, of course, these rituals are there because you can be more predictable. You can deliver the value for money that is very nice because. To be very honest, how many games are on budget?
Yeah, it fluctuates a bit. Let's say on budget and on time is
none.
So I wouldn't say none, but not a lot.
Not a lot. Yeah. So, but that's something that, from a software engineering perspective, that's more predictable, and to be more strict in the process helps to be more predictable. But there's also some downsides.
Yeah. It really, as a engineer myself, maybe I don't know if irritated is the correct word, but having to being able to just quickly react to something, I don't know, it makes work just more exciting or something, for me at least.
It also, of course, stimulates creativity.
Yeah.
To be not as predictable and have more things that bother you.
And because I'm always in the mindset, okay, maybe this is going to be not actually in the game, I try to create more generic constructs that I can reuse left and right.
Yeah.
So there's a little bit of a nice conditioning happening there.
Absolutely. So that's on agility, right?
That's on agility, and then I think we can go to full stack.
Yes, a great jump here. Yes.
Nice. You are getting better at this.
I actually am, yeah. And you're getting worse.
Yes. All right. So what's full stack for software engineering?
Full stack for software engineer. That's working on the front end, doing a bit of UX UI, but also working on the designing the screens. Creating a front-end framework on top of that, building the backend and the connection between front-end and backend, connecting to your database, having some knowledge of infrastructure. That's basically the definition of full-stack developer for software engineering.
Yeah, and in game, especially in smaller teams, when you have a team of 3-4, let's say, sure, you might have your modeler or you have your coder and your designer. But what you'll see is at some point there's going to be a mix match of everyone being able to do everything approximately. So where software engineers, you could say they're more T-shaped,
Yeah,
right?
more T-shaped, yeah, correct.
You can see it's especially full stack game developers, people that really consider them as full stack, are very cone-shaped.
Yeah.
They can do a lot of things, and there is of course something they excel at. So I would say, well, coding is probably my strong suit, but I can pick up Photoshop, I can pick up Blender, and do things like that.
So you can pick up Blender. Now you tell me.
I have to let you do something as well.
Yeah, that's true.
And it's invaluable to have approximate knowledge of a lot of things. If
true.
your 3D modeler has an issue, just being able to brainstorm with him is very valuable.
It also makes your team more diverse.
Yeah. So let's see what the full stack.
What are the treasures?
Yeah. So we're gonna look for some treasures and see what full stack is for
us both.
For the both. And probably we missed some things.
But
absolutely. The front end.
We're by no means complete.
No. But we have the front end, and of course the game itself is of course the front end for in-game development.
Absolutely, and the front-end facing websites. Yeah.
For a console application. Are you gonna dare?
Yeah, I'm gonna dare try the jump. Yeah, okay, I failed. But nevertheless,
I'll open it instead.
Yeah, I feel safe.
And then we have UX UI.
Yeah. Of course, what I mentioned in the intro for full stack development. Of course, within full stack developer, from software engineering perspective, you interact with your users.
And but in games, I mean, it's invaluable to have a good user experience, right? If your user experience is not good, then you don't have.
You don't play the game.
Yeah, exactly. All right, then we have graphics programming.
Yeah, no, not doing a lot of those.
No?
No, not.
Maybe if you work in blockchain stuff.
Yeah, if I work on the GPU.
Yeah, but in games, you have to do some graphics programming at some point if you want to have good performance. So compute shaders or shaders programming, things like that. Invaluable. Are you gonna dare this jump?
No. I'll let you do this jump.
And this is, I think, writing. There it is. Ooh, it's a bit dark from here because you're all the way over there.
Yeah, but it's
writing.
It's writing. So writing, yeah.
Story writing.
Story writing. Oh no, we have the documentation on the code. That's writing, but it's different writing, I think. So that's more capability for a game developer, I guess.
Technical documentation is important for sure.
Of course, but is it writing?
It's not writing a story, right? Come up with a story, writing dialogue, things like that.
No, it should be to the point.
Coming up with a beautiful name like Guy the Guide.
Yeah, that's something that we really work hard to create. So it brings us to the following treasure, and that is what's going to be backend development. Backend. Yeah, of course, that's something in a software engineering perspective. Of course, all our applications have a backend application to fit the logic. But from a game perspective, for the game backend or the game engine.
Yeah, and it's vastly different. You have your services on the backend, or if you have a multiplayer game, you actually have a server that handles all the multiplayer. It's your backend. But you can also have backend code within your client that handles all kinds of logic.
True.
But yeah, of course, both really needed.
So what do we have here? Animations. Yeah, we do have a lot of front end, but not that much animation. And if I need an animation, I go on the web and find one.
You go to web components and get animation. Well, I mean, of course, did not make this animation myself. The Unity people might have already see that we're using the Cinti Unity packages. But yeah, animations are involved. You need some animation if you're making game overall. They don't have to be good. Look at Vampire Survivors, a very popular game nowadays, or a couple of weeks ago. But you need some form of animation.
Yeah, absolutely. That brings us to the next one. Texturing. Yeah, the wonderful world we're in.
What is the last time you textured something as a software engineer?
Yeah, I can't remember exactly.
Ever had to create a cool texture for your console application?
No, not really.
Yeah, I mean, in games you need to, especially 3D games, you need some texturing, right? In 2D games a bit less, of course, because you have your sprites, but it is kind of important to be able to at least know how it works, how UVs work and things like that.
Yeah, absolutely.
And then we have
Infrastructure, yeah. I think both sides of the coins.
DevOps.
Have that, yeah, DevOps, yeah, of course.
Very popular term nowadays. And invaluable in both industries, I would say.
Absolutely.
Kubernetes, as we said, is things like that. And then we have, I think, your favorite.
3D modeling, yeah, that's definitely my favorite because it was something that I never did. And of course, you can imagine being a game developer, Alex created most of the game. But I created some 3D models that we're using within the game. It was really great doing that because it was something that was extremely out of my comfort zone, but something that I never did before, but was really rewarding that I finished it. And we'll be there in the requirements puzzle. You can see the result. And I was pretty satisfied with it.
Yeah, and I mean, 3D modeling is important. I mean, you need to understand how it works if you're a full stack game developer. And then finally, we have
the things that you never hear.
Audio, which we do not have here because
we're the audio, right?
We are the audio.
We're the audio.
There's wink, wink.
Oh, you're really going to do that again?
No. So yeah. So as you can see, game developers, when talking about full stack, there's a lot of things that they need to be aware of.
Broader spectrum.
And of course, it's not necessarily better or worse than a software engineer that is specialized. But personally, I feel it's very nice to just have knowledge of those things because you can talk with people about them. When you step out of your comfort zone, you learn new things. You're like, oh, whoa, this is also possible. This is also a possibility. The way I was used to is not necessarily the best way, and that only happens when you step outside of your comfort zone, when you try new things.
Yeah, indeed. And like Alex said, it's not the one or the other is better, but it's just different approach and you have different techniques. But being open-minded in using different technologies and being open to use that within a sprint, it makes it also very flexible if somebody's on holiday, for example.
For sure.
Let's move on?
Yeah, let's move on.
Yes, brings us back to the hallway.
Okay, and I think we have one
puzzle. Yes, the requirements puzzle.
Did you just step on my head?
I actually did, and this was again. I was faster than you were.
That's cheating.
Yeah.
All right. So requirements, very important, right? Especially if you work Scrum or Kanban, you need to gather requirements.
Yeah, you need to gather requirements. You need to know what adds value to what you're building. You need to know what's high priority, what the user wants. So really important to have great requirements and know what the expectations are that needs to be delivered.
And in software engineering, it's a puzzle, of course.
Absolutely, it's a puzzle. But like we discussed earlier, the puzzle pieces, you know where it's going. You know what picture is going to be there. You know what can be the result. But there's still puzzle pieces. You just need to be aware and find the correct position of the pieces, and then you can solve that puzzle like we're doing right here in our requirements puzzle with the nice 3D models.
You could say that through using requirement engineers or information scientists, information gatherers, software engineers actually have the whole requirements thing solved, maybe even.
Never solved fully, but it's solved more, and the process is more clear than from a gaming perspective, as we're going to see in a little bit. Because we tend to see where the puzzle is going, and we just need 3 more pieces. And
I wonder if people know already what this is.
I bet everybody knows what this is. It's one of my favorite Netflix series. Finished this year, I think, the last season. So. Casa de Papel, a nice 3D model.
Very nice.
It right?
Very nice puzzle, yeah. And then we go in the game development.
That also is a puzzle, right?
Yeah, it's a huge puzzle because it's the first thing that you want to do is make something fun. Your game has to be fun.
What's fun?
But what is fun, right? How do you define fun? I mean, can you define fun? It's something so extremely subjective. So then you start iterating, you start creating, you start making things, and before you know it, you end up with something completely different than what you had first in mind. You might start thinking, okay, I'm going to make this super cool first-person shooter, and in the end, you'll end up with, I don't know, maybe a third-person hack-and-slash game.
Yeah, indeed. It's much more complex to define things that are not measurable that easily.
Yeah, exactly. And that makes this whole puzzle very complicated, because you can't just hire a requirements engineer to that he's going to talk to people and gather the requirements for you. You have to come up with the requirements on the fly.
Yeah, true.
And you have to actually, maybe scrap user stories because they don't work anymore. It's like, you want to split it up?
Yeah, that's because the puzzle is not.
It's going to take some time.
Yeah.
So this is my favorite movie. Not to be confused with the show that. No. It was a decent show. Let's keep it at that. But so my experience with this is that I've become it really a user story that is not so insanely clearly defined as it is a lot of times within software engineering. Really leaves a little bit open for creativity for me as a developer. I can see, okay, implement double jump. You start with the double jump, you implement it, you're like, okay, this works, this is okay. And then before you know it, you end up with a gravity flipping button because that just is more fun. And then you show to people, oh, that's a good idea, that works fun. Or, hey, here I made a double jump and a dash, things like that. Oh, that's fun, we can add this. And really stimulates my creativity as a developer. Yeah. Having a little bit of more wiggle room in the implementation details.
Yeah, and I think that's something from a software engineering perspective. We have procedures for a reason to be, like I said earlier, more predictive and be on budget and on time.
Yeah.
But that limits a bit of the creativity and the open mind that you can have in achieving better results.
Yeah.
Not saying that you throw everything overboard, but just leave a little bit more room for yourself to evolve and be more. Yeah,
and some people might think now, but in games it's very easy to be creative like that. But it's 100% possible in software engineering as well. Different kinds of implementations, different kinds of algorithms you can use, making things faster. Just being creative about what you do.
So you can be creative in anything that you do.
Exactly. I mean, software engineering as game development are both very creative.
And brings us to the same topic actually, having some fun, because if you want to take something into account from this talk, is that having fun is something that is really important. Oh, are we going to lose the ball? No, right? I got it. Oh, you got it. Because creating this game as a presentation was also something that was not really done before, and was new for us as well. But we embraced
very experimental.
We embraced all the challenges and had a lot of fun doing it. And like I said, creating Easter eggs is something that's also familiar from a gaming perspective, but it's not familiar at all from software engineering perspective. But I think every application should have an Easter egg, and it should also be maintained because it's something you're proud of. You have a lot of pride in that application.
Yeah, and just having fun while working is very important, right? If you create fun in a game, you need to be able to have fun. Otherwise,
if you can't have fun, then the game will not be fun as well.
How can you make fun if you can't have fun?
Yeah.
And then there are people like, okay, I'm working at a software for bank. How is it possible for me to do fun stuff there?
Always possible.
ASCII art is fun. I've had a lot of fun with some ASCII art or fun code comments, and people, oh no, no comments. The code has to be clean in software engineering. But it's just, it takes away the joy, some joy from software engineering.
No, indeed, which is a shame, and I should really encourage everybody to do that within the software engineering perspective. And it's very easy to have some fun in ASCII art, like Alex said. Just mind the performance.
Yes.
Not every line of code you do.
Performance very fun.
You want to score.
Yeah, I do want to score because the whole point is to prove that the game developer can make the game. There we go.
Okay, you score.
Thank you for letting me score.
Yes, So, but also in this game, we added a lot of fun elements, Easter eggs. Please write them down in the chat somewhere if you found them. their favorite thing from me and from Alex. So
Yeah. Some personality traits, you could say.
yeah, indeed.
And I mean, personally, I've had a lot of chuckle from going through Git histories, Git comments, and finding comments from colleagues, funny comments, Easter eggs, things like that. And just brings a smile to my face, and it's important.
Makes the work this much more fun.
Yeah, and if you can't have fun at your work, then
then you shouldn't work. No, you should have fun everywhere you work.
Exactly. So I think we kind of are reaching
our conclusion. Yeah, epic steps.
The epic steps.
Yeah, we cannot run anymore, I think.
No, because that's dangerous.
It's dangerous on the stairs, so we created the fall safe. But as a conclusion, I think from looking at the presentation we had and the things that we discussed, if you take one thing away, and that is having the fun factor in your work as a software engineer as well. Looking from it from a gaming perspective, yeah, of course there are things that the software engineering community and the software engineering and software engineer in general have more experience with and have more done over the years. So that's something that everybody can learn from. But from software engineering perspective, looking at game development, I think we can really incorporate some nice habits from the gaming perspective.
Yeah, I think so as well. And having done the switch myself some time ago, maybe some people will ask, why did you do the switch? But I'll answer that then. But I really miss, people just all screwing around with each other, in the code bases, living some fun Easter eggs, or, just game nights or game afternoon, so to say. Those are things that really bring joy to work. And a happy developer is, I would say, typically a very productive developer.
Absolutely. So it brings us to the final stairs, right?
I think that does bring us to the final stairs. And again, there is no good or wrong. Both there's different maturity levels, of course. But in the end, those are some things that we believe could bring a lot of joy to a software engineer and really make his life easier as a software engineer.
Totally agree, but we have a game with no sound. That's not good, right?
No, no explosions.
No explosions.
There have to be explosions.
There has to be explosions.
And I hope this is not too, but as promised, explosions.
As promised, explosions. And like we said, we had a lot of fun creating these presentations. Just slightly different, like we said, than a normal presentation. But I think it captures what we want to highlight to you guys.
All right. Thank you very much.
Thank you very much. And to finish it off for Q&A, we have created a nice dance for you guys.
Completely with mocap and everything.
Yeah, we were in the green suits and we really had a lot of fun doing this. And you might recognize the dance. It's quite popular song from the 80s, but
before
leave
my
it in the
time.
chat. Yeah, it's before your time, but it's way in my time. So,
mocap.
Yeah, mocap. We're open for questions.
Yeah, thank you very much.
About our volume here.
Yeah, I think that was really impressive, especially, the JetBrains slug in the end. I was personally really impressed. It was very epic. And you raised the bar really high for all our speakers. I don't know how they're going to proceed now.
Sorry.
Yeah, that was
I'm just
cool.
going to sit here giggling at the dancing.
Yeah. We should start dancing maybe as
well. It's like a torn leg because we would have done it live.
Oh, yeah. And I have to say there were many great comments in the chat regarding the presentation itself and the format. I would just read a few so that you know that you're there. Like, it was cool how this game was made for this event, and so cool how this presentation is a game itself, and amazing to see how they have all these different game style, graphic styles in the presentation as well. And I have to say that I'm really impressed that you managed to talk and play at the same time. I find it really hard.
He's more.
For me, it was a little bit very natural being on Discord every night playing games. Okay. But for this guy,
yeah, that's why we created some fallbacks, right?
Yeah.
Because the original version I would have dropped in the lava like 300 times. So
as we said, very iterative process. So indeed, in the first versions, he died over and over again. And I was told, okay, you just need to practice. You need to get better. But at some point, we had to just put on the fail-safe.
Yeah, you don't know that I'm not getting better.
How many hours did you practice before the talk?
Practice. That would be a lot of hours. I think if you're looking at the amount of time that put in it, I think more or less than 300-400 hours, I think.
Oh, wow.
Somewhere between 200, 400 hours, 300 hours. Yeah, something like that.
Yeah, great.
But it was fun.
It was fun.
You need to have a calorie count somewhere in the game for dancing. All right, folks, it was fun indeed, and I would like to reiterate, you've created the mark that every other speaker will need to top from now on. The only thing I would expect, the bare minimum, is making a game using your own engine written in your own language.
No.
That would amount of time.
Yeah, that would raise
drastically.
Maybe maybe next time, maybe next year.
All right, but speaking of the engines, there was a question like, what engine was used to make this presentation?
Oh, Unity.
All right.
So we used Unity.
And now we know.
So let's get back to questions from the audience. The first one we'll start, that is really close to my heart, is what are the IDE and software tools do you use for the development of video game applications?
So, me as a game developer, I use Unity. I started with Visual Studio, but I switched to Rider a couple of years ago. Which, it is easier for me.
What's Rider? I mean, like, what's that? Never heard about it.
Rider. Well, I would say Rider is the JetBrains IDE.
Oh,
But I also, for my day-to-day work as a software engineer, I typically use Rider or IntelliJ IDEA. It's very easy for me. And then for Blender for the 3D modeling.
Yeah, I use Blender for the 3D modeling. And of course, as version system, we use Git, which is not that easy within game development.
Yeah, it's not as easy as the software.
Yeah,
that's true.
From a software engineering perspective, it's much more intuitive and more predictable. From the game development, you have your limitations, and if you know them, you can work with it. But it's
for image, for sprites and textures and etc. I use or Photopea, the online Photoshop, or Paint.net, one of the two. And Audacity for audio. Very basic, very free.
The best of the world.
Exactly.
So the next question would be, what are the life cycle development process steps for developing a video game application?
Sorry, what are the?
Basically, what are the steps? What life cycle steps of game development?
Life cycle steps.
Process?
Okay. I think it starts with a good storyline. That's, I think, the first.
Yeah, idea.
Storyline idea. Yeah. You differ from the line, of course, but
for me, it is first. I'm like, okay, you know what would be cool if you could do this and this. If you had a hack-and-slash game where you could rewind time, things like that, or a truly rhythm hack and slash, and then you start from that and you refine your idea, and at some point you're gonna be like, okay, this core gameplay loop really fits. It is really fun, and so you focus on your core gameplay loop, and once that is done, when you're confident that it's fun, you start adding things like audio animation, 3D modeling, expanding the world, creating your levels, and things like that, until to a point where you think you are done. Which, I'll be honest, from a hobby project, has never happened before. There hasn't been a time where I was like, okay, I'm done.
So do you start with some sort of game mechanic and then build it up from there? Just kind of get something running and see how it goes, and then try and add on graphics and things.
Exactly.
Yeah. When creating this game, we had a basic storyline, and that differed throughout the time, of course, but we work from that, and let's do level by level, see what we want to achieve, what message we want to bring, and what can we do to bring that message. So that's basically how we did it.
Yeah, I really like the idea. I love the guide you had there as well. That's a great way of introducing stuff.
Thanks.
Great slides. Honestly, you've ruined me for presentations now.
Oh, sorry.
That's great.
Just an nitpick from me, from my personal experience in AAA game development. When there's so many people and so many money involved, and sometimes marketing, I don't know, costs much more than development, and you have a set date, you don't have that much space and time to reiterate an idea. So on the high scale, you basically have 3 steps, like pre-production, production, and polishing. So, and basically you try to put as much as idea as possible in pre-production, and in production, all I hear is feature cut, feature cut, feature cut. So, and by the end of the development, you got, I don't know, maybe 30% of the original idea that you had, because you don't have time to implement all those great ideas. Okay, so back to the questions from our lovely audience. Do you use any like popular add-ons while in the development? I guess if you use Unity a lot, so maybe some plugins for Unity.
The plugins for Unity I use a lot, almost always. I start a Unity project with DoTween, so it's a tweening engine. Always use it. First thing I install. And after that, the new Cinemachine plugins from Unity itself. I always try to use that for my camera right now. And recently I've migrated all my hobby projects to the new input system from Unity. It was released like a year ago. And that has been the standard for me as well. And those are basically the standard Unity plugins I always install for any project. Before I even know what I'm making, basically.
Do you make heavy use of the asset store and the plugins that are available there then?
Ooh, so much use. Yeah, especially art, as much as I can find. I've bought, I think, every single Humble bundle that has been with game development assets. I've bought it. So I just have a library I can draw from, right, when I need things. So these assets that you see here are also bought from one of those Humble bundles, for example. When it comes to for really technical plugins, I'm, let's say, a stupid one. I try to reinvent the wheel as much as possible. The one plugin I use extensively is animation plugins. So and state machine plugins, behavior tree, sorry.
Do you prefer to use the plugins there rather than rolling your own for that kind of thing?
It's just not my for my cup of tea, so to say. And inverse kinematics, I tried to make it myself a couple of times. Did not work as good, and then I was like, okay, maybe I should just use a plugin for this instead.
You can then just concentrate on the things you need to concentrate on.
Exactly.
Yeah.
So the next question, pretty peculiar one. Do you know any norms like ISO or PGO and standards for developing a video game application? Before you answer, I would like to mention that there is a C++ standard committee WG21 that consists of a lot of game developers and who are trying to push as much as their knowledge and feature request into the C++ development, like standard library and language development from the standpoint of the game developers and their needs. All right, go on.
Oh, thank you for answering the question.
Oh, no. I mean, that's completely the C++ niche world and with a little bit of the game development. So yeah, do you know
the question was if we know starting points communities to get into game development.
Not exactly, like standards like ISO standards or
ISO standards. Oh, sorry, yeah. Us Dutch is thinking ISO instead of ISO. Well, personally, no. I'll be honest, I never had the curiosity or anything to look up for such standards in game development.
No, not as I'm aware of. From a software engineer perspective, there, of course, are lots more standards out there. Doing game development for this game. No, it didn't pop up.
No. So no, sorry.
All right. Oh, that's okay. Another question that hits really close to everyone's mind is how to switch careers from other industry to game development if you're a software engineer. What should be you focusing on?
That's a very tricky one, right? If you want to switch careers, yeah, I mean, I did it the other way around. I switched from game development to software engineering. If I were to switch back, so let's say hypothetically I want to go back into game development, I would probably start with hobbing a project seriously in the night, maybe cut down one day of work. And once I have that foundation where I really feel, hey, this is good, this can be something, then I would probably go and work full time on it. But as an indie, I don't think I would ever go work at a game studio again. Personally, I would very much just want to bring my own game out there. But you can always, I mean, there are game studios, big game studios. In the Netherlands, we have a studio called Nixus, which does a lot of ports, which is basically looking for traditional software engineers to help with the backend systems, with the porting systems, port pipelines, things like that. So that can be a gateway into the game industry. The more those kind of companies.
It's interesting you're talking about sort of software engineering and some of the software engineering disciplines and things. Coming from that world, unit testing, for example, is quite a big deal, sort of, especially with sort of some more of the enterprise type things. We've had a question on the chat asking about, do you unit test your games, and how? I guess.
We had the discussion as well because, yeah, indeed, unit testing is a thing, but it's really hard to test everything within your game. There are some options of unit testing game and behavior parts.
Unity also has a,
but not to the extent that we're used to within software engineering, because it's really widely adopted within software engineering. It's really mature. You can unit test at a really low level to a high level, and integration test, and you can automate everything, so you have a change somewhere in your code and you know what it reflects in the entire application.
Yeah.
And it's a bit.
It's so tricky in games, right? How do you end-to-end or how do you integration test a game? You have to check the state of your screen, basically. So personally, what I do is when I typically use Unity, which is .NET. So I have like a very detached core, basically a backend within the game, and that is what I unit test typically. And that is the logic manipulation that's happening there. But I never unit test user interaction, stuff like that. So if the user presses this, then this should happen, things like that. Because it's just so tricky. And Unity has tooling, but it's not very mature. But a very good example of this is Factorio. You can go on YouTube. If you go like YouTube Factorio unit tests, you're going to see that they have their own framework where they do something within the game, and their framework verifies that the screen has the pixels it's supposed to have, and then it flashes green or red, and then they do that super fast, and in the end you get like a breakdown how many red flashes there were and how many green flashes there were. So I mean, it is possible if you invest a lot of time in it.
Mm-hmm.
Yeah, I actually have to say that, the topic is quite great because probably that we do some surveys in the community, and especially in C++, every year I'm a little bit freaked out with the result when the people say like 30% of C++ developers don't use unit test. I'm like, oh, wow. And I mean, like, I was trying to validate what's going on. I asked them if they do use unit tests, but without some specific framework. There's still like about 20% who do some unit testing, but somehow manually, maybe, or with some custom frameworks. But like 30% still every year, they don't do anything. And the percent is even higher in the game dev sector. So and especially like game dev, embedded. These are the areas where I do expect people, do some testing, and I hope they just do some different testing instead, and they just say no, but they finally do at least something. Otherwise, I'm really surprised with that. Okay, actually, we're a little bit running out of time with the first presentation, so I would like to thank you. That was great. You set the bar really high, and now we would like to invite our next speaker. So thank you, Alex and Erik. Bye.
Thank you.
Thank you.
Bye-bye.
Yeah, and I would like to invite Victor. Hello, Victor.
Hey.
Yeah, glad to see you here. So before you start your presentation, your actual discussion with Alex about the plugins, I would like to use my question, which I ask every speaker today, is what was the first game you created? Could you tell us?
So I don't think I really have a first game that is worth mentioning, because what I like to focus on is making great tools to help people make games. So I like to see myself as someone that empowers people to make games. So I can think of many games that I have helped make, but nothing comes to mind as to something I would have truly made myself.
Okay, thank you.
So truly is your question.
Yeah, that's fine. Okay, I think you can start your great discussion. So we'll go away with Matt and we'll leave you here. So yeah.
Alrighty, folks. So this discussion is kind of a little selfish because I was kind of creating it for myself to feed my own curiosity, because I'm extremely into developing plugins, extending engines, etc. So I would suggest you to grab a cup of coffee or tea and just listen to our discussion about the whole environment of developing a plugin for a big commercial engine that's currently out there in the world. Victor, just give us, I don't know, in 2 sentences, an introduction of exactly what does your plugin do?
So 2 sentences is not going to be much, but our goal with the plugin is to truly bring next generation voxel technology to Unreal to really help people make beautiful landscape that can have caves, that can have procedural generation, that can make planets, that can make green worlds, that can make anything you can think of. And we want to help with the entire pipeline, be it procedural foliage, runtime editing for players, all sorts of stuff like that.
All right, but why plugins and Unreal Engine? How this idea has come up to you? How was the idea for the voxel plugin born?
It was born a while ago. So basically, at some point, I was very bored and I wanted to do something with Unreal because I had been mainly working with Unity so far. And I had played Astroneer quite a bit before that. Astroneer is an awesome planetary game where you can sculpt the world. And I was yeah, this is truly awesome. I want to make the same thing for myself. And that's truly what started me with the plugin. And I was I started with just releasing it open source. And then people told me that I should probably sell that for some money. And I was okay, this is kind of crazy, but I guess I'm looking to follow along. And yeah, several years later, I'm full-time on this and having a lot of fun with it.
So basically, you just by an accident run to the idea of making business out of the plugin.
Yeah, it's more I made the plugin and it kind of forced me to make a business out of it.
So you started to working alone, but how many people currently are working on the plugin?
So we currently have 4 people full-time on the plugin. And so maybe I can give you a small breakdown of what we're all doing on our side. I actually have a slide I can use for this. So let me just do this. So yeah, it's 4 of us, and I'm the lead engineer in a way. I do most of the core C++ stuff. Then we have Victor Goossens, which is, it's a small team, so a lot of people do a lot of different things at once. But Victor Goossens is more focused on project management, and is going to be the one saying that we actually need this feature, and I can't just mess around playing with the features I want to work on. Then we have Jared, which is doing an awesome work helping people, because one of the part of making a plugin is that you have pretty big community at the end of the day that you need to help. And so Jared is actually full-time helping all those people on Discord. And finally, we have another engineer since a few months, Elandas, who helped me to all the C++ stuff we do to add new features and things.
All right, so why I'm asking actually, because just recently I was at a conference and there was a presentation from one of the big games that are currently will be released in the end of this year or maybe in the beginning of the next one. It's a AAA topic, but what I was like not surprised, but what like just made me like made me sure that my idea of the typical game development company organization and roles it consists of. Basically, it was. Give me a second. I have it stored. Like 13% probably. Oh yes, 17% of all the people working on actually developing a game are engineers, and all other people are narrative, game designers, level designer, artists, street artists, audio designers. So what do you need to do to make a big game? Like a lot of people that are actually not engineers. So a plugin and creating a plugin is actually like a little bit a hack to get into the game development where you can just use only engineers to make something cool. Yeah, and speaking of which, so engineers are providing a plugin that creates these new features, but actually voxelization has several impact on both the art design of the game and the
That's true. Like we do have like a very wide surface of impact in a way. So that's what like something I forgot to mention. I guess that Victor Gusen is also like a technical artist. So he also helps with all that part of like making like material be fancy, all that kind of stuff, which I have no clue about. So indeed, like with the plugin, we're not only engineers, we also need to be a bit artists because we need to help game development companies make the best out of the plugin. So we need to be able to understand artists. We need to be able to work with all kind of like, as you said, different teams. So yeah, we do. When you make a plugin, you get a chance to focus on engineering, but you need to not forget about all the other part of the game development as well. And you need to make sure to talk to them. You need to make sure to help them in any way you can. And that's one of also the big upside of having Victor Gusen on the team, because they're always like, yeah, this is nice, but can you add like this one feature, which to me makes no sense, but which is like very helpful to technical artists because they can like help improve their workflow or something. So yeah, it's really interesting all that kind of plays together.
And how do you measure the resource budget of the plugin and its effect on the game? Because, for example, even not for the finished project, but if you have something extremely heavyweight on CPU or GPU bind, and it's, for example, limits when an artist or designer opens an Unreal editor and it takes, I don't know, 50 minutes to load the plugin and to process all the data, and then it runs, I don't know, and 2 FPS to actually run the game, it really kills the mood and desire to do anything with the project. So what I've seen actually in a lot of times that the even like designers would like to make the big worlds with a lot of features and a lot of complexity, but due to technical limitation, because they basically cannot work on the big scale, they were limited to small resources and were limited in their imagination. How do you work with the resource limitation?
So basically, we have like a very scalable plugin. So a plugin can do anything you want, but the more you want, the more you will pay in a way. So we actually kind of leave all that onto the teams that want to use it. So most of the time, it's like the technical artist of the team will start prototyping with the plugin, see what's possible at what cost. And that's going to be what's going to determine how much they can do with it. And they're like always very aware that, you can't get performance for free, so there's always a cost to feature. So it's never really been an issue for me. It's like we provide something and everything has a cost, and people like to benchmark for themselves anyway, so they just prototype with the plugin, see how much it costs and what features they can use for what cost.
All right, so like there's no metrics to provide the resource budget used by the plugin, so they would I don't know, figure out, okay, I'm making this world too big for the plugin to work properly, maybe I need to reiterate my idea.
So we do often have this kind of discussion with it about like how big your world is going to be or stuff like that, but it's usually limited to like one specific topic, which is memory management, because it's like one of the only metrics where we can be relatively have at least an idea of what's going to be the amount of memory used. So like if you have like a world of like 10 kilometers by 10 kilometers, we can be like, yep, this is probably going to use like around 1 gigabyte if players start to edit everywhere. And if you have like a smaller world, it can be, this is probably going to be under this budget. But even then, it depends on like the amount of edits players are going to make, the type of edits. It depends on like so many parts of your setup that there's no real way to provide like realistic metrics without prototyping. We couldn't be like, yeah, you have this amount of voxels, so this is going to cost this amount of memory or this amount of like millisecond per frame. It'd be nice, but yeah, you really need to prototype to see what's happening.
So getting back to the hardware requirements, what do you usually, how does the working environment for a plugin developer looks like? So for the game developer, you need to have like the beefiest CPU, GPU, because before the game is polished and finished, it will be extremely unoptimized. So you need as much resource put as possible to basically just develop and run the game. What about the plugins?
It's I would say in many ways it's very similar. You definitely need a very powerful CPU because you're still going to compile C++. So without a powerful CPU, you're just going to wait. On the GPU side, I would say the same thing as game development maybe applies. So you want like a powerful GPU, but not too powerful because you still want to like keep in check with what your actual target will be. So I was like actually discussing with one of my clients the other day whether they needed to buy like a 4090. And I was like, 4090 is probably like way out of scope because you're going to lose track of like what people are actually going to play the game on. So yeah, I would say like probably like a mid to high tier GPU and a very powerful CPU is what I would recommend for a plugin.
All right, and getting into the environment, do you use like a CI/CD pipeline?
We do actually. I can show you some of that if you'd like. So we have like we use like GitHub Actions. And so what we have is we have a trigger every time we push something to the plugin repo. We have a build machine that's going to fetch the plugin and package it for like different platforms. So that's most of the CI we have. It's like mainly checking compilation. That compilation works like in editor, on Linux, on whatever platform you can think of. And we don't have any kind of like automated testing for now. We do want to add some automated testing to some extent, especially related to like asset compatibility. So like, loading like old assets and checking that you can still package them, that there's like no errors loading them. And I don't think we will ever be able to do full-on testing where we can like test every feature with automated testing because that's something that's very hard to do with game development. But I do hope that we will be able to do some amount of automated testing because it would be actually very useful to be like, yep, I can make changes and I can rely on the CI to tell me if I did something wrong.
All right. As I see GitHub Actions, but how does it work with the proprietary SDKs and like building plugins for some platforms that are not openly available?
So it's a bit of a trick question, but the simple answer is that we currently don't target these platforms on GitHub. When we have clients targeting this platform, we have access to the SDKs through them. And so basically we see like they're doing the beta testing for us in a way for this platform because we don't have access to this platform otherwise.
I say question with Game Engine is it's Unreal Engine, the plugin for the Unreal Engine. And speaking of the environment for the Unreal Engine, what is your how does your release cycle looks like? Is it like feature based or like agile based, sprint based? So
I would say it's pretty messy. So that's what I would qualify our current release cycle. Mainly due to the fact that this, as I said before, it's like I've been making this plugin for fun, and then at some point it turned into a business. So a while ago, I think I have like a slide somewhere I can maybe show this to give you some context. So yeah, so like at first I released on GitHub when it was open source, and then I released on Gumroad, I released on the marketplace. I released like a few versions when it was mostly feature improvements. So it was like 1.0, 1.1, 1.2. And then when I switched to working full-time on the plugin, I kind of went dark in a way, and I'm kind of working on like a big 2.0 release, which has a lot of cool stuff, but isn't ready for release yet. So we haven't really had a release since Q4 of 2020, which is why it's pretty messy right now. So what we do want to do moving forward is follow some kind of something similar to the Unreal versioning. So like you would have like 2.0.1 for like a hotfix, 2.0.2 for another hotfix. And if there's like a big new feature, it would be like 2.1. And yeah, hopefully that answers your question to some extent.
All right. And the next question was, how do you deploy your plugins? So I know from the first hand, because I've made quite a few plugins to support integration, Ridev, and Unreal Engine, that official Unreal Engine Marketplace allows you to upload only builds of the plugin for the last 3 official releases of Unreal Engine. So for example, if it's currently the official release is 5.0, you are allowed to 5.0 for 27, 26. So, for example, how do you backport features, etc.?
The short answer is that we don't, because supporting 3 versions is already a lot. So the amount of code required to support the old version is actually quite a lot. So we usually only support like the 2 latest version, maybe the 3 latest version. And if you have like, basically, if someone is like still on 4.26, it's a pretty big studio that's like locked because they're like already in production. So what we do is that they just reach out to us and we try to figure out something for their use case specifically. So if they need specific features, we can just like work on backporting these specific features instead of backporting everything. But yeah, generally speaking, we just support the latest version and maybe the second latest one, but not much further than that.
Why I'm asking, because we had a few requests from pretty big studios asking for 4.19 support because they have custom branch of the engine. And as far as it goes, I think the Mortal Kombat 10, that wasn't like, it's an old game, but it's not old, was made to using the Unreal Engine 3 when the Unreal Engine 4.19 was already in the wild. So you're kind of missing on the big projects right now without support for the older versions.
I think it's pretty interesting because on the plugin side, basically you're not going to start using the plugin in the middle of production. It's going to be something you're going to start using at the very in pre-production. So what we see is that the people we're talking with now are like people in pre-production, and so basically they're also like on latest Unreal version. We actually never had the issue of like not supporting older Unreal version has never truly been an issue for us, I think. Because if you don't use a plugin already, it's unlikely that you're going to start using it, unlike like a more simpler tool, like something like editor only or something like that.
All right. One thing that I've forgot to ask, apart from the hardware requirements, of course, you need a beefy computer. What are the software requirements? What tools are you using with the plugin, and what skills, like language or pipeline stuff, do you need to know to make a plugin in Unreal Engine?
I think it's pretty much the same as game development. In Unreal, so I use Visual Studio with ReSharper. You can use Rider. You can use whatever JetBrains tool of your choice, I guess, since we're on this stream. So it's mainly C++. There's a bit of C# for the build system of Unreal. And then there may be some other scripting languages if you want to make a CI pipeline, you can use some other languages. But mainly C++ would get you very far.
All right, and if you would get access to a genie from the Epic Games company who would grant you any wish and improve the environment and pipeline and stuff, or the feedback queue for plugin developers, what would it be? What would you improve in the current situation? So
on the engine side, I would say there's not much to improve. I'm already very happy with all the interfaces we can get. When one of the most annoying thing is when you want to use some engine features that's not exported. When the DLL does not export the feature, because then you can use it, but it's not going to link, which is always very annoying. But you can always reach out to Epic, and most of the time they will help you with that in the next release. I would say the thing I would change is probably on the marketplace side. There are a lot of people complaining about the marketplace for very good reasons, because we're missing quite a few features. So if I had a genie, I would probably give the marketplace a lot more funding and a lot more people to help make it a even more awesome place. All right. So actually, what I've missed, I wanted to run the presentation of the games that actually use your plugin, so people basically understand and figure out what is your plugin and what's used for. Sounds good. Should I just go through them maybe? I am currently
can you open your presentation, because I think I have something work with one. So just to quickly show what projects your plugin can sneak into if you are working on. So as I see, working on a plugin or any middleware technology kind of opens gate into the game development world, in the terms that you kind of have an option to collaborate with different studios, with different games. So making a plugin that's widely acceptable and that is easily integratable can get you to talk with many game development studios and work on different small and big projects of yours. So kind of ran through pretty quickly with almost all the questions that I had for the for our interview. So maybe we can get down to the questions from the audience, if we have a lot.
May I drop a
Sounds good.
question if you
Please go
agree
ahead.
with that? Because I'm really interested. So I'm like, I was listening to you and I felt like maybe a little bit confused, because I was thinking like, should I start creating plugins for game development, or should I start with actually implementing the games? So what would be the choice? So how should I decide? Because this all sounds fantastic, but like, imagine I'm a complete newbie. So, and I'm thinking where to start with as maybe transitioning from software development to game development. So where is it better to start? What are the pros and cons? So what would you recommend?
So it's actually pretty fun, because I would say it's like a very gray line between the two, because you have a lot of people making a game and making like an awesome system for the game, and then at some point being like, yep, I can probably make a plugin out of this, and then just move the code to the plugin and like start selling this plugin. You see, I think maybe 50% of the plugin on the marketplace start like that. And same for the plugin, you can like start making a plugin and then make a game out of it. So I think what matters is really what you want to make. Find an idea you find fun, focus on it. And as long as you make tech for it, like the tech will not disappear, you can like then make something out of the tech. But yeah, my point would be start with doing something and don't worry too much about like making a plugin or a game. It's going to work fine in the end anyway.
Okay, and talking about the learning curve, maybe like for the newbie, like for example, so how is it different to the learning curve for the game development, or is it just the same? I mean, like, do I have to learn any extras or maybe something different to create plugins?
I am very tempted to say it's pretty much the same, because a lot of the time you also want to make plugins for your game as like part of your design, like as part of your project management. You probably want to already make plugins in your game so that they're like neatly like separated features. So I would say they're pretty much the same, and there are like only very few technical like knowledge you need to know to make a plugin. Like you can just like go through the doc in like probably half a day, and you're going to know everything you need to know about plugins. So I would say the important part is, yeah, the same. You're going to be using the same Unreal features. You're going to be using the same C++. So it's pretty much the same like learning curve.
What I would suggest in this case, so you kind of can get in a situation where Unreal Engine has a lot of feature actually integrated into it, but it's disabled by default. So you can easily get into a situation when you are making a plugin for the feature that has been there for, I don't know, for centuries, but it's not like properly documented. Or maybe there's like tons of the marketplace plugins. So making a plugin, I would say would better start with actually making a game, a specific game with specific limitations, gameplay mechanics, etc. And in order to fulfill the requirements, you kind of create a plugin. And from that point, you kind of already know your target audience and you know how to kind of market it. By the way, how do you market your plugin?
That's another fun question. I would say mainly it's like word of mouth, and that can be like on Twitter, that can be on Discord, that can be on Reddit, but mainly it's just like, you know, every few days you post like a tweet about some feature you're working on or something. That's how marketing is done, I think, for the plugin. And in a way, it's also pretty similar to like marketing a game. You just regularly post nice screenshots or nice videos about your game, and you hope for the best and that people will find you at the end of the day.
But isn't it like harder to push people like to know and to learn more about the plugins? Because I think like the people say, okay, so I need to create a game. I will take the game engine and I have everything. Why do I need some extra plugin from some third-party company? Why do I have to think about it? So how do you push people to actually dig into it and to believe that they really need it?
So what you need is to show some features that's like unique and very visually appealing, I think. So one, I mean, I can show a quick example. So if I just open this video. So like if we look at something like this, it's something that you cannot see in like the regular Unreal Engine. It's like you're like procedurally like spawning trees using like a brush modifier. You can like move big brushes, and you're like, okay, I want to generate this huge world. I can. At first, you're probably going to try using like the Unreal landscape, and then you're going to be like, yep, I need more than this. And then you start looking online for new tools, and that's where the plugins come into play. So it's more like marketing needs to come later almost, because it's people need to look for you first and need to fulfill a need. So people need to find out they need the thing first, I would say, before. It's not like you can force people to use a plugin. It's like you find a problem, you fix it, and then you just have to tell people that, yep, this is how I fixed it, and people will encounter the problem, will look for the problem online, and will find you eventually.
Okay, so
It's
to
not
me
like
it sounds like it's maybe the same as complex as maybe marketing, profiling, because until you actually run into the problem, you don't know you have it, and you are not thinking about the solution. You are not looking for it. So that's not something
Maybe
really
to some
obvious.
extent, yeah.
You can think in advance. Yeah. Okay.
I like to think it's a bit easier than profiling, because profiling tends to be very technical and pretty hard to see. Whereas like for us, for instance, it's like, okay, you want to make a cave in Unreal, you're going to look for some YouTube videos on how to make a cave. And at some point you're going to be like, yep, probably like find a video about us or find a video about like voxels, and you're going to be like, yep, is there like a voxel plugin for Unreal Engine? So it's a lot more organic, I would say, with features like that, because you're like, yeah, I want to make caves. It's not like I want to make my game faster. It's I want to make caves. I want to have this specific feature. How do I make this specific feature?
Okay, cool.
It kind of sounds a problem of a chicken and an egg. So in order to market, you need to showcase, and in order to showcase, you need to a consumer that actually uses your plugin.
Yeah.
Yeah, kind of this kind of problem. So I'm actually wondering, so who are usually the creators of this kind of plugins? Are these usually the game studios who run into some issues and started creating the plugins, or are these completely different, companies who are just, keen on creating plugins? So this chicken egg problem, how is it going there?
So from my experience, a lot of the people are people who work on the game. Maybe for companies, but for companies, it tend to be trickier because you have like IP issues, because like the company owns the IP and they're often like not interested in like actually selling the plugin. But a lot of the time, yeah, people working on a game and making an awesome game and making like an awesome plugin in their game and being like, yep, I want to extract this plugin and I want to share this plugin with other people as well. And yeah, to me, that's like the top story for like plugin creators: making a game, making awesome features for the game, and extracting a plugin out of it.
Okay, cool. And maybe you can name just a few other known examples of the various plugins for like different engines, so that we kind of understand the scope for the plugin. So what are usually the functionality covered by the plugins?
So I'm not going to be able to name much for Unity, but for Unreal, which is what I'm familiar with, you're going to have plugins that I mean, it's such a wide landscape, but you're going to have like editor plugins that help you with editor shortcuts that help you make you much more efficient in like the editor. So we'll have stuff like I think it's called like Node Assistant in Unreal, which lets you do a lot of makes you like work a lot faster with Blueprint. So you can just like drag your mouse and it's going to auto-connect the pins for you. It's going to do a lot of fancy stuff like that. Then you have like game features plugin. So you have like a lot of locomotion system, a lot of system around players. So like, a plugin that lets you like ride a horse, or a plugin that lets you kill other people or stuff like that. And then you're also going to have like more, I would say like us, like more landscape-based plugin maybe. So like plugins that help you make water for your game, that help you make landscape for your game, that help you with procedural generation, that help you with procedural foliage. So truly you have like all kind of plugins, and it's pretty hard to like throw pretty good landscape of them.
Okay, cool. And yeah, by the way, the audience, if you name some cool Unity plugins, because we're discussing Unreal plugins, you can name them in the chat. We'll be happy to learn more. I actually have a question regarding like these plugins. How often do they become the part of the mainstream engine? So do they usually merge at some point of time, or do they still stay independent? So what's the usually, life cycle for such plugins?
So it depends. So I guess you mean do plugins usually get integrated into Unreal itself at the engine level?
Yeah.
So this is more of like a business question, I guess, because it depends on like whether Epic is ready to buy the plugin or whatever, or like the plugin company. And there are like a few examples of plugins being bought by Epic, but I think it's really like more on like it's probably like one or maybe 2 or 3 examples like that. But most of the time they stay on independent.
Okay, interesting. That's interesting. I don't know, like if anyone from the audience knows some similar stories about the Unity, we'll be happy to hear them in the chat, because I'm really interested in how this, like, it sounds to me like 2 parallel curves in the game development, those who are working on the, maybe even free, like the game engine itself, the games and the plugins, and they kind of interact. So I'm wondering at what point of time and at what conditions do they usually merge into each other's, and how often does that happen? So just to understand how the market looks like.
No, that does make sense. And what I like to think is that when you work on a plugin, you're very close to working on an engine, because you follow the same principle. You need to like care a lot about like code quality in a way, probably more than you would like for code that you can be used in one game. You need to care about APIs. You need to care about docs. So in a way, it's very similar to developing for an engine, but you're like more limited in scope, I guess.
Okay.
There is a good question from the audience. So with the libTUZ 5.0, was it hard to migrate your plugin to a new version? So yeah, that's a question.
Yeah, so Epic did a very good job with 5.0 with adding a lot of stuff to make it very easy to migrate. So I think migrating to 5.0 was like literally like half an hour of work on my side. And of course, it's been more work as we migrate individual features and we need to work with the new features. But overall, it's been very, very smooth.
And there's another question for the volumetric capture. Do you know any other plugin apart from the OptiTrack?
I have no idea what this means.
All right, that's fine.
Okay, I think we more or less run out of the question. I would like to thank Victor here for being with us and for great discussion, and thank you, Alex, for leading the discussion and bringing so many cool questions. And we actually learn about the plugins, and how it all really evolves in the game development. So thank you, Victor. And we'll now move into a great point in our session today, a raffle. So the rules of the raffle are very, very simple. So we'll read out the question loud. First of all, we won't give you any answers or any tips. So the first person to write the correct answer will contact you and give you a prize. So that's simple. So Alex, let's start maybe with the first question. So you can select the one you find the best.
All righty then. So the first question for the most good listeners of the first talk, and the answer has actually been said, that what year was the first games to use Unreal Engine 1 released?
Yeah, great question. So for those who remembers the talk, or for those who remembers the timeline of the Unreal Engine. So let's learn how many Unreal Engine developers do we have here. 2010. No, that's not a correct answer. 1997. It's closer, but not yet. Yeah, we have the correct answer. 1998. I guess Dixie was the first. So I'll contact you later regarding the prize. So Alex, let's run the second question.
And the second question again runs close to the first talk. The guys used the Unity engine. And the question is, at what company's conference was Unity engine announced?
Yeah, so you can maybe repeat the question, so if anyone missed that.
All right, so the question is, at what company's conference was Unity Engine announced? And I think most of the guys will be like Googling right now. Okay, no, not Googling at all, because we have few wrong answers before we get the right one. The Patricia Harrington with the Apple. That actually surprised me a lot, because I would expect any basically other company apart from Apple to actually present the engine.
Oh, yeah, that's right. So I guess Patricia was the first, if I'm looking at the chat correctly. So I'm writing down the names here so that I can contact you later. Yeah, and it was not GDC, you know. I like GDC a lot. We've been there many times. We plan to be there in 2023, so do come to our booth. But it was not GDC, not a game development conference, really. Okay, maybe let's run the last question for the raffle, and then we'll have one more surprise for you.
All righty then. So one of the questions that will be in view with one of the future talks that we have about the UI in the Unreal Editor. The question is, what technology was used to write the UI of Unreal Editor 1?
Oh, what a tough question. I'm wondering what it could be. C++, no. C, no.
Not the language, but the framework. So I would give you some examples like WX widgets, the Microsoft Foundation class library, or Visual Basic, or maybe the dear Ingui, the praised, the lord of all UIs used in the modern game development.
There was like answers like Qt and Slate know that these answers are incorrect. So do we have the correct
I
answer?
think Mr. Erakst has given us the correct answer.
Okay, I still don't see it, but oh yeah, I see it. Yeah, that's correct. So it's like, yeah, it's
Yes, it was Visual Basic used for the OG version of the Unreal Editor.
Yeah, that's correct. So congrats to our 3 winners. So I'll contact you in the next couple of hours to talk about how you can get your prize. And now we have a small surprise for you. So before we go to the next talk, we have here, ta-da, Matt, welcome back.
Yeah, big surprise. I had no idea Visual Basic was used for Unreal. That's a good one.
Oh yeah.
Go figure.
So we have actually Matt here for the reason. So Matt is ready to do a small demo.
Yeah, so I'm one of the developer advocates for Rider and a bunch of other stuff and everything. And I thought I'd show you some tips and tricks of Rider for GameDev. I can take a look at some Unreal stuff, on Unity stuff. And since we've got a nice audience here as well, if there are any questions, anybody asking for some interesting tips or tricks, then please fire away, send me some questions, and we'll try and answer them. And of course, with you two here as well, you two know Rider very well too. So if you see me doing anything wrong, or if you see any other tips or tricks that I could throw in,
throw
please
tomatoes.
fire away. Don't throw. Be nice. Don't tell me off or anything.
Joking.
Okay,
good. Share the screen and go on with the demo.
Right. Yes. Yeah. Where's? Oh, I thought I already had shared my screen. It's gone. 1 second. Sorry.
Sure.
Yeah.
Sure.
Oh, that's what I did. I pressed the wrong button and got rid of it. There we go. Okay, so there we go. We have Rider. We have two instances of Rider running here. No, I'm still in the wrong window. I have a Rider showing a Unity game and a Rider showing an Unreal game. So if we just stick with Unity to start with. If you're not already familiar with Rider, it's the kind of IDE that you'd expect it to be. We've got the project view on the left-hand side here. We can view all the files that are related to your project and open those up in the editor as you'd expect. When we're talking about Unity, we show the project as a Unity view here. So we've got your assets, and if I just close that down a minute, we can see assets and packages, and you can open those out, and you can navigate around and go find your source files and open them as well. First tip I'm going to show you though is 2 keyboard shortcuts, and these keyboard shortcuts are really important. And if you get these, you can really pretty much go and do anything. The first one is Shift, and this is search everywhere, and will get you to anything there. Doesn't matter which keyboard, which key map you're using for this either, because this will just work across all the key maps. Shift is really useful. You then just start typing. So if I want to go to the main menu, I'm going to start typing main menu, and it will search for all the things that are associated with main menu: file names, symbols like class names, and other things as well. So let's just go straight to the type, and that will then navigate me straight there. It's really useful. Shift, and then start typing. You don't have to type the full name. You can do things like TDISS to get to the Tower Defense Input Scheme Switcher. This is a great way of navigating around your code, because quite often the you give class names which are sort of lots of different words stuck together, and you quite often get a very unique set of characters there. So it's very quick and easy to jump around your code just by doing TDISS and what have you. Once you're in a file like this, you've got syntax highlighting, you've got all the sort of things you'd expect. You can fold your code and collapse things down, all this kind of stuff. But you'll notice there's lots of squiggly lines here as well. And again, if you're not familiar with Rider or the other sort of IntelliJ-based IDEs, these are the inspections that we run on your code. So we index your code, we'll check all your code there, learn what's going on, and use that index to run analysis on stuff. So we can look for problems with your code or give you suggestions, and it can be a whole bunch of things. It can be things like there might be a null exception here, or it can be things like, if we have a look at that return there, we've got, say, an inconsistent body style. So we want to try and help you write better code, write code with less problems in it, but also keep you sort of nice and consistent, keep you've got lots of writing the normal sort of style. It's also useful, especially with things like with Unity, to help you bring your C# level up to date. So this one here, for example, there's nothing wrong with this code here. It's fine to have a getter like that with a return statement here, but more modern C# can write your code a bit more tersely and use the arrow syntax there to provide a simple getter. We've got other things here like, we can make this item private, and there it's also telling us that we're not matching naming rules there, so it might want us to capitalize that I. We've got another inspection at the top here. What's someone saying? Got virtual members but no inheritors. Okay, well then, oh yes, the second keyboard shortcut. That's the whole point of this. The second keyboard shortcut, Alt-Enter. It's our doing action there. So once you've done Shift to find something, we've got our inspections. You can then use Alt-Enter to make these quick fixes and to automatically rewrite the code once we have found these problems or issues or suggestions for your code there. So I can do Alt-Enter on this particular one here to say we've got virtual members, nobody's inheriting it, we don't need them to be virtual. And here it's actually suggesting that we can make the whole class sealed. And if we open that up as well, we can actually run this quick fix across the whole solution as well. I'm going to do it with this one file, but if we do that, it'll very quickly rewrite the code for us. We can see the markers on the side here giving us the difference of what's actually been changed in the code as well. So we've got version control built in, which is really nice. And so it's good. And it's like, actually, I can roll those back very easily or undo them and so on. So the 2 keyboard shortcuts you want is Shift and Alt-Enter. If I just pop back over to here as well, there's no squiggly inspection going on here, but there are still things we can do from Alt-Enter, which is really useful. So we've got context actions that are available as well. So it depends where you put the mouse cursor, sorry, the text cursor. So I'm on the name of the class there, Alt-Enter, and I can then quickly change that to be an internal class or a public class, or I can create a default constructor. I can even create a factory method as well if I wanted to, or make it into a partial class, and we can then start to make more interesting stuff going on as well. We can navigate about things. We can navigate up and down the type hierarchy. So I can see what this derives from. I can see that I'm deriving it from input scheme switcher, and we get to see this item here. But the other key thing to show here is these last items down here: navigate, refactor, inspect, and generate. These are the entry points into pretty much all of the functionalities that Rider has available to you. So you can use this navigate to, which gives you a nice context menu of all the things you can navigate to from this particular class name. So things like base symbols, who it's derived from, and we can see derived from input scheme switcher, mono behavior, and ultimately object. And in fact, we can even navigate to mono behavior, and Rider will decompile it on the fly, and so you can actually see what the code is of mono behavior. We can do things like find usages as well. That one's not going to be particularly useful on the class name, so I'll come back to that one. Related files, derived symbols as well. So if there were classes deriving from it, this is a sealed class, that's not going to happen. Yeah, usages. So let's just go and find something which can do as usages. So our paused function there, if I go to navigate to and find usages, then Rider will very quickly show me that it's only used in one place. So that would be better. It gives you, it can give you a big list and allow you to navigate around your code and find things. Other useful things in here, the refactoring, so we can do automated refactorings on your code. So there's lots of different things you can do there. The simplest and most useful of these, or the one which is probably most used, is the rename refactoring. So we can actually rename your code across the whole project safely. So if I've got something which is being, which is named fairly similarly and the name's used in lots of places, I can rename it much more securely than if I just did find and replace. Which is really cool. Other useful things are things like safe delete. So I can just, I'm not sure I want this class anymore, I'm going to delete it, but just check to see if anybody's using it first, which is a good one. And also I can move the class around, I can pull methods in and out, and I can do proper refactorings without having to cut and paste and move things around and stuff like that. If we switch over to the C++ game, so we've got an Unreal project here, and this is, again, very similar look and feel there. It looks exactly the same. We've got our solution on the left here. Again, if we're using a Unity game, we'll sort of split that down into assets and packages, so you get a view of it very much like in the Unity game itself. But for Unreal, we show you the solution there. Now, one thing which is really interesting here is that I'm on a Mac. And normally that wouldn't work because Unreal generates Visual Studio solution files, and of course Visual Studio as a whole isn't on the Mac, other than with Visual Studio for Mac. But what we can do with Rider is we can load up those projects, so we can understand. We don't load the Visual Studio project here. We actually load the U project file. So if I can open this, we can actually see now that the root of our project is our U project file itself. And so we can actually load that directly and use that to load the whole project. We don't need to generate the Visual Solution project file here at all. And so we can load that, and we've got all of our files as you'd expect. If I go into my source, I've got my game, all my private files, my public files. And so, for example, right, shoot a game. Then again, a fully syntax highlighted editor as you expect, collapsing and all that kind of stuff. And we've also got inspections and alt enter here. And again, we've got our shift. And again, this is what we want to be able to use to be able to navigate around and go and find things. And so if we want to type controller, again, it'll go off and it'll search for all kinds of stuff. It'll search for files, for classes, for symbols, and for all kinds of other useful information. So if I wanted to go to my player controller, I can just navigate here and it will navigate around. And here as well, we can see, why am I quite so, lots of things being highlighted here. So yeah, again, we've got the inspections in our Unreal game as well. So we've got lots of highlights going on here, and we can say that these are being can be made const. This one is going to tell us to be the variable can be moved inside the if statement, which is very nice. And again, our Alt-Enter keyboard shortcut is the doing action here. And if we do that, we've got a quick fix for our action, and it can move us in there and sort of, again, make our code just a little bit more concise. And if we do Alt-Enter again, there's no inspections here, there's no squigglies as being shown. but it shows us that we've still got these entry points into all of our functionality. So we can navigate to something, refactor something, do inspections, and generate code as well. So I can navigate. Is this going to be a good thing to navigate? Let's do navigate on that one. And so from here, I'm on a method and run the get shooter HUD function. I can navigate to the declaration of that, and just very quickly, it'll jump to it as well. Of course, with the, you can do the whole sort of control click items as well and navigate to code there as well. Looks like I've navigated into the engine itself here. Yep, there we go. So we can index the code, index the engine, and navigate around and take you to lots of different places. Let's just jump back to Unreal. Does anybody have any questions yet? By the way, I can see there are some comments in there. Anything that we want to cover just now? I think I'll just keep going. I'll just show some more stuff. However, I've completely forgotten what I was going to show next. The points. Oh yes, generating code. So we can see now we've got our Alt-Enter items here. So if I do it on this is paused, I've got options I can do on there, and down the bottom I've got my entry points to navigate and refactor and inspections, but I can also generate code as well. And we can do a whole load of interesting things here for generating. We can generate constructors, properties, overriding members, equality, and so on. And down the bottom here as well, we can generate Unity event functions. So this is really useful if you've got a mono behavior and you want to be able to generate code. You can then say, well, pick and choose whichever ones that you want to select. You can see there's some documentation down the bottom there as well, a little summary of what the method does. Select those, and it will very quickly generate those code for you. So we can do that nice and quickly, get you up and running, take away some of the boilerplate that's going on in there. In fact, we can see now that Awake is actually implemented in the base class there, and it's automatically called base for us. Of course, if I just get rid of that, we can, of course, do that ourselves as well. We can type awake, and that'll override that, or we can do something like late update, and we can just type, and it will automatically generate these functions for us, which is pretty cool. Now, one of the things we can see here, though, is that these functions are grayed out. Awake is grayed out there because it's a redundant method. It's not doing anything other than calling base.awake, so we don't particularly care about that one. And we can do Alt-Enter again to remove our redundant override. But late update here, this is one of our event functions which Unity is calling. And in fact, we can see we've got a little hint here above us showing us that this is an event function that's being called every frame by Unity, but this one's being grayed out. And that's because Unity's calling it, but it's doing nothing. So if we had something in here, debug.log hello world, now we can see now it's no longer grayed out because it's doing something. But if the method itself is empty, then we're doing work when we don't need to be doing it. And so we've got an inspection here now to tell us we've got a redundant Unity event function. And again, we can Alt-Enter and clean that up. And in fact, we've got a lot of Unity-specific and Unreal-specific inspections. And so if I just quickly jump to some of these, I can show you some. So one of the nice ones I like to show, actually, I mean, this isn't an inspection, but it's a little feature that we've got for Unity support, is that we recognize Unity colors here as well. So if we've got, look at that, that is the, where are we? It's the color in Unity engine.color core module. There it is in the namespace Unity engine. So it's Unity engine.color, and we can see that it's red, and it's showing us the red, the green, the blue highlights. And if I do pick color from palette, I can actually, oh, that's gone, that didn't work. Oh, okay, that doesn't want to show that one for me now. Well, then if I, let's try this one instead, new color, 155622, whatever, that should now show me a highlight. It's decided to fail. There we go. We've got colors back in there. I'm not quite sure what's gone wrong there. But let's move on to something slightly different. You can't have a good demo if something doesn't go wrong. More interesting inspections that we've got for Unity are the things that we want to try and help you do at edit time that would normally happen only when you switch back to the Unity editor. So for example, here, if you call new on a mono behavior or a scriptable object, Unity is supposed to create these. Unity creates the object, wires it up with a native object behind it. And if you create a new one, that doesn't happen. But normally you wouldn't see this until you reach this point in your game. And then you get an error in the Unity console, which tells you that actually Unity should be creating this itself. We can show this in the editor for you. We show it as a warning there. And again, we can give you an Alt-Enter keyboard shortcut to convert it then to the right method. And this is going to be to add a component on a particular game object. We'll look around to see what game objects are available. You can use the game object passed in as a parameter there, or the object on this, and you can quickly select that and rewrite your code. Same thing for scriptable objects as well. So we can help you create those objects. And this is something that we want to try and do time and time again, is to try and stop you having to swap to the Unity editor or the Unreal editor and realize that you made a mistake and then have to swap back to the code editor to then fix it all there. So we want to try and find these issues up front and help you fix them. So things like classes, methods which are annotated with specific attributes, like this runtime initialize on load, that requires a static method. So we can very quickly give an Alt-Enter to fix up the to fix up the missing static qualifier. Things like even do draw gizmo, which is expecting component and gizmo type, we can very quickly rewrite the code there to fix that code up for you. Similar things with other ones. So that one is saying incorrect method signature. So if you just fix that up, we're actually giving you a choice of two things here. We can either have a plain hash shortcut or something which takes an argument as well. We can do more useful stuff because we do a lot of indexing of your whole project. We can do more interesting things like magic strings there. So Unity has a lot of magic string happening going on in there. You can call methods with magic strings. You can also define things in the Unity editor, which you want to be able to use yourself. So tags, layers, input values as well. And we can help with that. So instead of you having to remember them, swap back to the editor, realize that it's wrong, come back to the code, we can show you what they are up front. So here, for example, we've got Unity engine, the input get axis, and this axis is unknown. We haven't defined this in the editor itself, and so that's probably not going to happen. What we can actually do is invoke code completion, and we can see the items that are available there as well. So it's like, okay, I wanted horizontal, and we can see now that the warning is gone. Similar thing with tags. We've got a player tag here. We've got an unknown tag, and it's going to tell us that the unknown tag isn't available. And yet, it'll also give us the completion for all the tags that we have defined, which is very cool, even when you're comparing it against a string literal like this. Same with layers, same with scenes there. Lots of cool, useful stuff. And also then with methods too as well. So we've got, we're calling invoke on fire projectile. And in fact, I can do control-click and navigate to the fire projectile method. And when I was doing find usages before, so if I do navigate to find usages, this is going to show me now everywhere that this fire projectile method is being used, even when it's being used inside a string, inside one of our magic strings, which is pretty cool. And in fact, what I can do is if I do rename on that fire projectile now, it'll rename the method and also where it's being used in string literals, which is a really useful way of trying to keep your methods correct there. What other cool things can we show? Lots of useful ones for things like redundant attributes. So if you've got a serialized field here which has got, well, if you accidentally assign it to a property, which is very easy to do, but not something that's actually going to work, we're going to show that it's redundant, that it's not actually going to work on there. If you've got serialized field and non-serialized, it'll tell you that it's not useful there. Things like initialize on load. If you've got don't have a static constructor, then there's no point to it. But we can now either remove the redundant attribute or create our static constructor there. So there's lots of things we can do there to sort of help you work with your code. Excuse me. More interesting ones are things we can do to help you with best practices, things which are related to performance, and things which are going to be, some of them are going to be micro optimizations, but when you are working inside an update loop that's going to be called very, very frequently, you might want to do this. Things like here, for example, we are repeatedly accessing the Euler angles property on transform. This is actually going to make a call to a native object. So this is actually repeatedly doing that is kind of inefficient. So we'll call that out and we'll actually say introduce a value, a variable, and it'll create a variable there. So you only have to access it once. And so you can do that. We can do the same sort of thing with position here as well. So we're repeatedly accessing position. So that's repeatedly going to go into native code to get a new copy of it. And we can introduce a property here. But what's interesting is that it's being used here, but we don't show a warning because we're actually modifying it via local position there as well. So it's smart enough to know what's going on and help with that. Similar kind of example with set float. This is setting an animator property and a shader property by a string name. But the first thing that this method is going to do is going to convert that into an integer ID. And so if you do that every single time, you might as well use the cache property index. And so we can then cache that as a static method up front and allow you to then use a more efficient method. Similar simple problems with things like comparing a tag against a string literal. This is going to allocate some memory there. It's going to call it's going to call into native code, allocate some memory, and it's much better to use the compare tag method. And you can do that very quickly with Alt-Enter, or we can, as you saw before, we can actually do that in bulk and run that across a bunch of things. So if I fix it up across the whole function, we'll rewrite everything for you. Other useful ones are if you're instantiating a game object and setting the parent, the transform, then that's doing two different things, and it has to invalidate and rebuild an object as it goes. But we can actually combine that into a single call, and Unity can be more efficient with that and work better. Finally, I think for the inspections for Unity, and then we'll have a look at something else. We've got a performance context, which is a really interesting feature whereby we know that some parts of your code are being called much more frequently than others. So we know that the update method is going to be called every single frame, and that could be called very, very frequently. So you want to avoid expensive calls here. And here we're kind of trying to follow some of, again, Unity's best practices that they've published, and avoid some expensive calls inside a very frequently called method. So you can see here we've kind of highlight event functions with this little link here to show us the mono behavior the update is a method on mono behavior. And in fact, if we click that, we can click on view documentation and we'll get a link to the docs of what the method itself does. But you'll also see now, hopefully, if it's not too small, that we've got a little fire icon there as well. We can show that it's a hot method. It's going to be called very, very frequently. And therefore, we want to avoid doing anything too expensive. And we can see we now got these highlights on this get component, for example, there. We've got this orange underline. This is a different kind of highlight than what we normally show, which is the squiggly warnings. And this one is just a bit of information. It's not saying there's something wrong. There's not something you need to fix necessarily, but you might want to take a look at this. Get component is expensive, and you don't really want to be calling it every frame. So we highlight that to show you that it's an expensive method, and you might want to look at this in a profiler. You might want to measure it to see whether it is expensive, whether it's something you particularly care about and want to re-architect your system for, or whether it's something that's absolutely fine. Similar sort of thing with camera.main. I know camera.main was made more efficient in recent versions, but it's still doing a bit of a lookup, which you perhaps don't want to be doing every single frame. We can actually do this sort of transitively as well, which is rather cool. So we're highlighting here reset enemy. And if we navigate to that now, we can see that's because reset enemy is calling get component. And if we go to, in fact, I think it's find target, which then calls reset enemy, we can see that it's doing there. And we can see now that reset enemy is also being highlighted as frequently called. And if we click this now, we can see, well, why is it being frequently called? And we can actually see, let me just show you that again before there. If we click on this method, this frequently called annotation here, we can see we've got this show incoming performance call, critical calls. And clicking that will then show us our call tree of where it's being called there. You can see it's being called reset enemy, it's called by find target. And if we open that, we can see it's being called by update. And then we know that update is very, very frequently called. And there we can see now our entire call stack. So if ever you're in Rider, sort of deep in your code somewhere, and you see this is being highlighted as frequently called, and it's a bit of I'm curious as to why, click that link and then you can navigate it. You can also disable the performance analysis for it as well. And you can also say, actually, I don't care about this. Reset enemy is not going to be called that often, so don't worry about it. It's not expensive. And now we add this comment here, and that sort of propagates around as well. And we can see that the highlights have gone. So it's a very useful way of giving you some information that there might be a performance problem here. It's not telling you there's something wrong. It's just giving you a hint about something that is useful. I think that's enough Unity for now. Let's give a bit of Unreal a go. Or have we got a question?
There were a few questions in the thread, so I think maybe we could answer them before we kind of running out of time in 10 minutes with the demo and don't have time for that. So the question first was like, can you show an example when you want to use basic completion via smart completion? So generally, can you show maybe some difference between them where one is better than another, really?
Yeah, so basic completion versus, what was the completion you said, sorry?
Just smart completion. Yeah.
Yeah, so the idea here is basic completion is just going to complete something here. What have I got in the, so if I start typing, I can get item. That's my sort of basic completion there because it's trying to find what's available in the local area. If I want to use smart completion, then let's say I've got a string of name there, and in my method up here, I know this is going to break things, but this is just an example. String, I don't know, output. It doesn't like that because, yeah, okay, because update isn't there. Here, if I wanted to do basic completion, then I would get a whole lot of everything. So I've got things like, reference equals get in whatever print, it's got all of those. Whereas what I can do is I can just do smart completion instead, which is a different keyboard shortcut. And what that does, it'll narrow down the things that we show to things which match the type of what I'm after. So normally we will complete anything and everything that's in the current context. But here now we're trying to complete just the things that are in string. So here it's giving me output because that's a string. It's got name, it's got tag, and it's useful things I can do. It's also given me methods that can return me a string or a type of T in the local context. And it's just a narrow set of options to give. And so that can then be a bit smarter and a bit more useful in the things it can show you. But the other interesting thing is what you should really just do is just start typing. What we've tried to do is make it so that the automatic completion is a bit of both. It kind of gives you all of the things that you want. So it gives you all the things in the local context, but it will sort of prioritize the things which are of the right type. You might ask why we don't have smart completion on all the time. And the reason is smart completion here doesn't allow me to complete a method call that might return something that I can then use to get a string from. So I can't sort of do that. So if I had, where are we? We've got camera.main.name. I bet that's probably a thing. So camera.main.name, I can use that to complete. But if I do smart completion, then camera isn't in there. So I can't do that. So normal completion is supposed to kind of give us all the informations. But yeah, I've lost my train of thought there.
Okay,
That
okay.
helps.
We have a few more questions, so maybe run for them. So there was some discussion about the themes, like dark and light theme, and I maybe would like just to comment here that the people might kind of be a little bit confused about, like, because they say that the dark theme is only available in the paid version. That's about the Unity, not about Rider. In Rider, you have them both, and you even have theme plugins, so you can actually have all custom colors you ever dreamed about in your IDE, and you can use this custom theme, or you can get something from the marketplace. So, and select between many color themes available. So yeah, here is the dark theme if you prefer the dark theme, because like, yeah, Matt, they ask you to use the dark theme.
Yeah, I find that it's better to demo. I use the dark theme personally, but it's better to demo it in the light theme because the contrast is usually better if you're, even if you're on a smaller screen.
Yeah,
or on a
same for
projector or something.
me.
Yeah, light.
Yeah,
presenting
right.
light is better.
Okay, there is a question about the naming convention. So I noticed Rider tends to favor Microsoft naming convention over Unity. I tend to favor Microsoft too, and Rider always suggests I change member names to use an underscore, for example. Can we choose?
Yes. So we've got in the preferences, we've got, if you just search for naming, you can go to code styling C#, and then we've got a whole bunch of different interesting naming conventions that you can have here. You can specify these through editor config as well, or you can edit these and have them how you want. So you can have an instance field, for example, being in lower camel case there. And I've also got an additional thing here. You can add extra rules here so that you can have multiple rules. It'll prefer the first one, but then it'll also say, this is fine, I'm not going to complain about it. So if I wanted to add in another one, which had an underscore prefix and was all lowercase, then it would no longer complain about that. The one sort of awkward thing there is that this little bit of UI here isn't customizable by plugins, so the Unity support can't add its own custom rule into there as well. So the Unity support has a naming rule for serialized fields, and we can add it here. So I can add in a prefix of Unity underscore, and if I just save that now, and if I have a public string my serialized field, can't I? Now we should get a warning to say, actually, that should be Unity underscore my serialized field, because I had the wrong naming field there. And in fact, if I go to this inspection, naming, inconsistent naming, and I go to change naming rule there, this should take me to the actual editor there. So I can now remove that prefix, and it will now tell me it's correct. A similar thing, if we have this with a non-serialized, then it's actually going to have a different naming convention. It should actually tell me that that should be capitals, but I think I've probably changed my rules too much now. And so you can have separate separate naming rules for serialized and non-serialized fields.
Okay, thank you. So we have maybe just a couple more minutes. I don't know, maybe if you want to demo something or you want to answer some other questions before we run to Tom's presentation next.
Well, I ran a little bit out of time on some for showing some Unreal stuff. So then very quickly, I think I want to just show some very cool things in Unreal here, which is that we've got integration with Blueprints. I'm in the wrong file. Pickup. One is that we will index your Blueprint files as well. And once this wakes up, you can see here we've got a link here which tells me that this class is being used in 3 Blueprint classes here as well: pickup, health, ammo, launcher, and ammo gun. And if I had Unity running now, if I click those, it would navigate to and open the Blueprint editor for that. And it also shows me down here fields that are being used inside the Blueprint there and what the values are. So we're using P launcher ammo and so on here for these particular particle systems. This respawn time down here is being used in 2 items. So in default pickup ammo launcher C and gun there, it's got the value of 20, it's got the value of 5 in these particular assets there. It's a really, really cool feature of bringing your sort of serialized data into your editor, sort of keeping it, showing you what the values are in your editor while you're using the code. Unity does something very similar as well, and it shows you the values which are being used in assets of your serialized fields. and it's a really, really cool feature.
Okay, cool. Thank you, Matt. So thank you very much for your demo, for your cool presentation. I think it's time to move on, and I would like to invite Tom. Hi, Tom.
Hey,
Nice to
hello.
see you. Yeah, actually, like we know Tom, I guess, for ages because of his great Unreal Engine course and some great collaboration with us in the past. And I just recently occasionally learned Tom actually lives in Amsterdam, where I do too. So we finally met in person. That was great. It's always great, you know, to see the person like for the first time when you know him or her for like many years in the internet. So that was great. So yeah, thank you for like collaborating with us for a long time. And if you're interested in some cool course about Unreal Engine, you should ask Tom about it. He could like kind of recommend you one, which is great. Yeah, okay. So Tom, before we start, my favorite question today. So what was the first game you ever created?
I guess the first game that I ever created was one based on Mafia 1. And I, like everyone that starts making games, somehow wants to make an MMORPG. So I tried to turn Mafia into an MMORPG for some reason. And I think I used some tool called like Realm Crafter, it was called. So it was mostly scripting. So I'm not even sure what kind of programming language it was. Maybe it might have been C# or something. And so of course that went nowhere, but it was still a lot of fun to just learn like so many things and do a lot of 3D modeling, because that's actually what I was more into at the time than coding. And so, yeah, of course it went nowhere, but I still managed to sell those assets on TurboSquid at the time. So I made a little bit of money on it, even though it never turned into a game at all. So yeah, that was my first game-ish.
Sounds cool. You should probably send me a link.
Yeah, I have it. I have some screenshots somewhere deeply buried in my Google Drive.
Okay, cool. Okay, Dan, the stage is yours, I guess. You can start.
All right, thank you. So welcome to my talk, Unreal Engine game optimization on a budget. And in this case, on a budget mostly refers to like cheap, easy to do optimizations in Unreal Engine, rather than writing complex custom systems. I'll show you some custom systems, but mostly it will just really be checkboxes and out-of-the-box features that are available that you might just not know about, or not know, or not sure how to use. So we'll be showing a few built-in profiling tools and commands. I'll show you some easy optimization opportunities and the significance manager. And I'll finish off based on how much time is left with, so like a did you know that this existed? Because those are always fun. So first off, who am I? Well, I'm Tom Looman. There's my Twitter handle. I started off at Guerrilla Games a long time ago. Had a little bit of time at Epic Games as well. But for the most part, I've been an indie developer and Unreal Engine consultant, just helping studios, well, in this case, optimize their game. So that's what some of these findings came from, and some of these screenshots are coming from as well. And I've been using Unreal Engine for probably more than 10 years. Started with Unreal Engine 3, actually with Unreal Tournament modding, but that was like much earlier as well. And I spend a lot of my time creating Unreal courses and tutorials. So I have a Unreal Engine C++ course, and maybe hopefully later this year, I hope to have a actually game optimization course. So this could be sort of like an introduction to that. So before you start profiling, every talk starts off with a few things to remember to do. So I'll just repeat those here. You want to start off with disabling VSync, disabling any kind of max or FPS limiters, set your smoothing of the frame rate to false in your project settings. And make sure your lighting is built, because if you have unbuilt lighting, a much slower path will be used, and it basically kind of invalidates a lot of the profiling that you're doing. And it can also really help to have map check errors fixed. This is done with, this is very useful. For example, maybe over time, some assets became corrupt or have invalid materials, or just set up incorrectly. This can have especially effects on what could be performance, but it could also be like load times could be affected by this. And of course, it's ideal to use a packaged game for your profiling, but I can imagine that standalone is very convenient to use, and I also do that sometimes. But make sure that timings and especially memory can be quite out of sync, because it might be that, especially in non-cooked builds, it uses different paths for loading assets, and it will still have a lot of metadata of the assets still loaded in. So be mindful of that for sure. So then you start off with finding the bottleneck. So you might be bottleneck on the game thread, the render thread, or the GPU. Of course, it could be other things as well, but these are like the 3 main bottlenecked areas. For that, we have Unreal Insights. That is one of the tools that we'll be showing today. We of course have the all-time favorite profile GPU, with the option to first run r.rhi set GPU capture options 1. That's a whole mouthful, and what that does is it enables a bunch more console commands in order to give you a much more in-depth information when running profile GPU. One of those things will be individual material and draw calls information, so you can actually see what went into your base pass or into your shadow rendering, rather than just seeing the total cost of your base pass or the total cost of your shadow rendering. So it can be very useful. But of course, that is more expensive, so keep that in mind. Don't enable that and then start doing Unreal Insights, but just enable that and then just do your profile GPU. And then, of course, you have the things like stat unit graph or even stat detail that gives you the most information on frame timings and all these individual threads, like the game thread, render thread, GPU, and gives you a nice graph to see if your frame rate is actually stable or if there's some kind of hitching going on as well. And then you have things like R screen percentage. If you set that to something really low, like 20, or just like 20%, you can get kind of an idea whether or not your GPU bottlenecked if there's no change at all. And the same is true for a pause. If you pause your game, this will actually freeze the game thread from ticking and running a lot of its logic. So that can sort of like give you an idea whether or not the game thread is affecting your performance or not. And then with memory loading, we again can use Unreal Insights with Unreal Engine 5.0. The memory profiler got a lot better in Unreal Insights, so that's a very interesting one. I haven't been able to deal with that that much yet, because the games that I've been helping optimize are still in Unreal Engine 4, but that's a very exciting new feature. And load time and file are other categories for tracing in Unreal Insights that are very useful for finding individuals. So seeing all the individual assets getting loaded and how long they take and when they get loaded exactly. And then we have other tools like memreport, load times dump report. I'll be talking a little bit more about all of these throughout the talk. So then let's first have a quick look at Unreal Insights. Don't worry that this overview is not really readable. It just shows you one frame, including all the individual tracked and traced function calls. And so the really powerful thing with Unreal Insights is that it can give very detailed CPU and GPU insights, memory insights, file loading, like when a file is getting loaded and what will happen on the CPU once it's loaded. For example, after it gets loaded, maybe it has to create a physics body, and you will actually see that all on the timeline. And you will see all the threading information, which is really powerful as well. You can see how threads follow each other up and what is running where exactly. So I'd like to give a quick overview of Insights without this becoming a whole tutorial for Insights specifically. So in order to run it, you want to run your game with dashed trace equals and then the categories of the trace channels that you're interested in. And then the dash stat named events gives you additional name information. I think this is especially for the CPU tracing. If you want to know all these trace channels, there's the rather long URL there, which has all of them listed as well. And you can run this in the standalone game when you specify them as additional launch parameters. But of course, running this in your package game is going to give you more accurate results. A really interesting thing to do, to add and to use is bookmarks. It already exists for garbage collection, sequencer start, which is like for your cinematics, level streaming when they get requested and when they are completed, and whenever you do a console command. So when you, for example, run r.screen percentage 20, it will show up as a bookmark in the timeline of your insights. So that's very helpful. And you can very easily add your own bookmarks by just having trace_bookmark macro through your C++ code. and then adding some string to identify like what was going on. So this could be any kind of gameplay context you want to give during this profiling session. You can also add your own stack profiling. So this is very helpful in order to get additional information and sort of like break down bigger functions and their costs into smaller pieces that are originating from your own C++ game code. I have a blog post about this for more details, so we can sort of like skim over it today. And it's really powerful because you might have a function that only says blueprint time, and it might be 1 millisecond, but you don't know exactly what's going on in that blueprint time. But it might be calling a bunch into your C++ code, specifying your own stats macros will give you much more detailed information. Like, okay, actually this code of us is actually taking up a significant portion of our blueprint time, for example. And as some quick tips, it's useful to run some commands during the session. So, for example, you can use pause to pause the game thread and really see how this affects possibly also your render thread, because some things from the game thread get pushed into the render thread, such as skeletal mesh updates that happen in the start of your game thread, and then they get pushed into the render thread, and then that gets pushed into the GPU. So if you pause your whole game thread, then you might see this having an interesting impact on your render thread and sort of like get a better insight into how they operate. And it's a good idea to only use the necessary categories for lower overhead, because the more trace channels you use, the heavier the profiling is, and so that might have an impact on your profiling. And of course, add those custom bookmarks for gameplay context, because you don't have a visual element to inset sessions. It's just a big timeline with all the threads. So you might get lost on when things were happening. So having some bookmarks, even for example, when your character interacts with an object and then some puzzle thing happens, it might be nice to just add a bookmark to that code and then have a better insight of, okay, this is when we triggered some interaction code, and you can dig deeper into that frame specifically. Then mem report with the optional parameter of -full. It runs a bunch of individual commands for memory profiling. One of the really nice ones that I like is obj list class, and then you can specify a class, for example, static mesh or atom sequence or body setup. And the mem report gives you a pretty good initial overview of like, okay, how much memory is a certain category using. And then by using obj list class and specifying a specific class, you can see from within a specific category, like atom sequences, you can actually see, okay, which is our most expensive animation, and why might that be? So here, I hope this is readable. This is one output or like a section of the dump log from a obj list class atom sequence. And so you see the paths to a bunch of these assets. Now, these assets are actually really cheap because the columns are showing the size in kilobytes. So it's like between 7 and 1 kilobytes. Others will be much larger, but they fell out of the screenshot. And there's two things really interesting here. The first one saying, is any object much larger than expected? And the other one is, are there any objects here that we don't expect to be in memory at all? Very easily, references get introduced in our reels, so very easily you accidentally load things in that you don't want to have. And so this is a very good first look at seeing why that might be happening. And then you can use other tools such as the reference viewer to investigate why that reference might exist and why it might have been loaded. And of course, make sure you do this in packaged games, ideally, because if you do this in the editor, you get some idea of course, what it might be loaded. But again, if you have opened up some window before in your session, that might still be in memory. So it's already skewing the results. And also, for example, with atom sequences, they're probably at least twice the size in the editor rather than in a quick build. So now let's move on to dump ticks. This is a super useful little feature, like a console command. You have dump ticks. You also have dump ticks grouped, which gives you more of an overview of like, okay, we have 17 of this component securely ticking. And it puts all the actors and components because they, of course, can tick independently. If you have disabled actor tick, it has no influence on the actor's components, whether or not they are ticking. So using this to dump into the log and investigate, like, is there maybe something ticking that I wasn't even considering existed or is definitely not currently relevant? Then you can have a bunch of ways to fix this. Either you just disable ticking on it entirely if it never needs to tick. You can use something like level streaming to load it in at a later time, or you could maybe use something like significance manager to manage the ticks, whether or not it should be ticking based on certain parameters, which could be distance to, like based on if it's more than 10,000 units away, we currently don't have the tick because it's not going to have any meaningful influence on the gameplay or frame. Then list timers is another useful thing to have an idea of like what is actually currently has been moved into timers, and make sure that you run it on a low enough frequency, because what might happen is if you set it on like a 60 Hz frequency and your game on old gen is running on 30, what might happen or what will happen is your timer is just going to run twice a frame, and it's not nicely spaced out. It's not super smart about being some kind of asynchronous function where it runs twice equally spaced inside of your frame. No, we'll just tick the timer twice, which of course is super wasteful. You're just actually making it worse. So make sure that if you use timers, make sure it's actually an optimization. Another good thing to keep in mind is just avoid heavy load. Otherwise, you just get very stuttery frames. If your solution to optimizing your tick is to just move a very expensive function to a timer, it might not be a great idea, because the thing is, then you sort of get these, like I was saying, these stutters, these hitches. And if you have a moment where other expensive stuff is also happening in that frame, maybe a bunch of actors get spawned in that same frame, you suddenly have a huge hitch. An alternative to that would be either to optimize the code itself or to use something like time slicing, where if you're iterating over some kind of array, to only do the X number of objects every frame. Of course, it is a little bit more complicated code too. Ideally, you just don't want to do that within this on a budget. And then we have stat U objects, which I really like because it sort of like dumps all the, or it currently shows all the ticking U objects on screen. This is really nice because pretty much anything kind of derives from U object in a way that would be ticking. So your character mesh would be included in here, all your blueprints would be included, or your other components, anything that's in the world would be listed here as it's updating and it's ticking. And you can very easily see either things that you weren't expecting to be ticking or that are taking up much more time than you were expecting. So that is really nice. And they're, in that case, I believe they're grouped per class. So if you have like 17 of a particular blueprint ticking, then they are accumulated as a single time. So you can see like, okay, we have way too many of these ticking and they're taking up 2 milliseconds. We should really investigate this. Then a quick note on like collision and physics. Like Unreal Engine is configured to be very to just work and be very pretty out of the box. Like immediately your physics will work. If you click set simulate physics on an object, and it will just roll around and interact with everything. That's really nice. But the downside is it's kind of heavy, and a lot of games don't really need this. So if you look at the character movement, that's actually not using physics. It's not using any kind of forces. It's actually using queries to sweep and check if it can move forward or if it can move down with gravity, and if it can slide along the floor or like along the wall, rather than actually using any kind of physics simulation. So a lot of the times you can disable physics on objects, and whenever the object is set to collision enabled, that actually means that it's both physics plus query. So you can set it to query only in many cases, and that avoids the object and its collision from being injected into the physics engine, which is just a waste of memory if it's a static object, but it's also even worse when it's a movable object, because then it will constantly have to move within the physics engine as well, even though you're never really using the data from the physics engine. Another thing it's very useful to do is just disable collision on all the components in the world that can't be reached by the player or that the player can't interact with. Again, this it will reduce the load on the physics system and on the collision, but it will also just save some memory. And in order to figure out how much memory that's using, one way to figure it out is using, again, obj list class as body setup. That can sometimes be 100 or even 200 megabytes of data that, for the most part, might be sort of like a waste. And especially on older gen hardware, this is kind of a problem because you don't have a lot of memory to work with. But at the same time, this also wastes a little bit of time during loads because you're creating this object. When you're spawning an object, it has to create a physics body and insert it into the physics engine. So it's just an easy way to reduce the load. And then with stat physics and stat collision, you can get more information about what is happening in a frame, how many line traces are happening, and how much time it's taking. Another thing I really like is show collision pawn and show collision visibility, because these visualize in your viewport the current objects and the shapes of your world and how your pawn, how your player will interact with that, how it's getting blocked on that channel. So pawn and the visibility are those channels, and that's very useful because you might be surprised just how many things are set to collision. You can also see just how complicated some collisions are. I mean, especially if you use a lot of marketplace assets, they might just have tons of convex hulls for no particular reason other than that it's very accurate, but it might just be a waste and be heavy on memory and on performance. Another quick tip: landscape. It can use lower MIPS. You literally have a variable or two actually called collision MIP and collision MIP simple, I believe. You can use a higher one, maybe 1, maybe 2. It really depends on your landscape. But this can significantly again reduce memory and reduce CPU cost, because your landscape can be quite detailed, have millions of triangles, and your collision may not have to be that precise. So then on to moving scene components, especially when you're dealing with just moving up those components and doing that in Blueprint. It might happen that you accidentally move it multiple times in a frame, and it can be a move or a rotate. If you do that, make sure you just call set actor location and rotation at the same time, rather than first moving it and then rotating it. Because in this screenshot, as you hopefully can see, on the right we have those two chunky blocks with move component with a yellow bar. So here we have a little robot that is first moved and then it is rotated. So we spend time updating all of the component transforms on all the scene components twice, and then we're triggering overlaps on all those components twice. So that might actually have a gameplay impact where other overlaps are getting triggered twice in your game world if you do some kind of gameplay with that. So that's definitely a useful thing to consider, and you can very easily find these things with Unreal Insights, which is super nice because it might be much harder to find by just being in Blueprint. One way to go around this is using a movement component. You can create a custom movement component in C++, write your logic in there, which is not that difficult to do. I actually hope to have a blog post about that soon to make sure that people know how to do that. But it's rather easy. Again, disable collision, very helpful. Just disable anything that doesn't really need it, or set it to query only if you do really need it. And generate overlaps is also very expensive. Again, you can see here that it takes a bunch of time to generate and react to all those to that movement. So just disable it when you don't need it. Another nice trick: auto-manage attachment. This is built in on the audio and audio components and the Niagara components. I mean, also some Cascade, but it's being phased out. So the cool thing about this is that while the audio is not playing, or while your Niagara system is disabled or like not doing anything, with auto-managed attachment, it will just sort of like detach itself from your player, from your whatever gameplay actor you have in the world, and it sort of like sits in wherever, like world 0. Only when you then activate the sound, it will reattach itself. And the nice thing about this is maybe your audio is not going to be active for a long period of time, or that particle is only happening when you're shooting something. The rest of the time, you're no longer paying for moving that scene component. And in order to profile this, you have stat components, which gives you some insight into how much time it costs to move all those components in a frame, and also how much time you're spending on calculating the bounds. So that's the next thing. You can enable use attached parent bounds on scene components, and then the nice thing about this is it will use the parents bounds that are already calculated. So here we have an object on the left, the bottom left, is a moving little robot, and every single scene component there, which it has a lot of, has its own bounds, but they're mostly the same anyway. So we might as well just reuse the parents' bounds instead of individually calculating them for all of these components. And in order to visualize this, you have either in-game you have show bounds, or in the other you have show bounds or show flag.bounds 1. And here in our insights, you can see highlighted all these. These are all the calc bounds that are happening in that same movement that I showed earlier. And individually, they're really short. They're really fast to do. These are not particularly complicated, most of them, but it's still a wasteful, and it's super easy to just make sure you reuse the data that's already available, especially if you have actors that have 50 components that are being moved constantly, or you have a spaceship that is consistent of like tens of or even hundreds of actors. The other thing you have to keep in mind is, for example, if you have a character and has a sword in his hand and you're using the parent bounds of the character, make sure that that sword can never really go out of the bounds of that player character, because otherwise, maybe if your viewer is only going to see the sword, it will sort of like disappear because it was not in the bounds of that character mesh. So do keep in mind that things might get out of bounds, so you have to be mindful of that. Then a quick word on Significance Manager. This is another nice system that is mostly just an empty framework. And the point of the use of the system is to use your game code to figure out whether or not an object is currently significant and should like do all of its sticking and all of its traces and everything, or if it's really far away from the player and it's no longer significant, so we can skip on a lot of these things. Maybe we just disable all the traces, or we reduce the tick rate, or anything like that. One easy way to do that is with a distance to, just out every frame based on the viewport of the player. You check the distance to that object, and based on that, you compute a significance value. There's no set way, but an easy one would be from 0 to 1. You really decide. And based on that, you can react to it. Say like, okay, when it's 0, it's really not significant, so I'm just going to disable a whole bunch of stuff. Careil doesn't really specify how to use this, so it's really up to you how to implement this and what your considerations are. The way I've seen Epic use it with Fortnite and Paragon is that they put their objects into buckets. So maybe on the platform, you might have 5 players in a multiplayer game that are in the first bucket, so they are always able to be on the full fidelity. That might be your own player, but also could be like your teammates, for example. They would be first. They would be the most important ones. But if your teammates are really far away, then maybe some other player that's really close by, so enemy player that's really close by, is in that first bucket. And then there's some profiling commands available, but also there's an example that I've been working on. A really simple example. In this case, I made a significance component to really easily add this onto other objects. And the nice thing about that is you don't need to have a C++ base class in order to implement this. You can just have, you can add this, C++ component to your blueprint classes, and then very easily implement what it should do, when it gets insignificant. And I'll be hopefully making a blog post about that soon as well, to give you some more insights. Now let's move on to occlusion culling. With the frustum culling and occlusion queries, we can prevent a lot of the meshes from actually being rendered. But if you have thousands of actors or thousands of components, this in and of itself can be really expensive to even consider. So you can spend 10 or even more milliseconds to trying to figure out what it should be rendering. That can be quite wasteful. And by the way, how occlusion queries are pulled, they are actually pulled in the next frame. So a bunch of queries are being sent out, and then in the next frame they'll be used. This is why you might also be seeing some popping when you're moving your camera around really quickly, and there's a lot of contrast between maybe the meshes that are being rendered and the background. So that might actually be because there's a 1 frame delay that you might miss and have a hole in your geometry for a little bit. But the alternative would be to actually wait for all those queries to be done, which is also not ideal because that even makes it all a lot slower. HLOD, or hierarchical LOD, can greatly reduce occlusion costs. Here in the screenshots below, you can see just how many. So those green boxes represent an object being occluded or having been queried, actually. And on the right, we made this mesh, that little building, into an HLOD. And so it's only one mesh once you're far enough, once you're pretty far away from it. But when you get closer, it gets replaced by all the modular pieces again. And in order to profile this, the main one would be stat init views. This gives you a really good insight into what actually is going on and how many queries have been triggered, how many objects have been frozen called before even being bothered to have been queried. And with the R.visualize include primitives, you can actually see that visualization happening. Another tool I really like is RenderDoc. It integrates pretty nicely with Unreal as well. And you can see the occlusion results by using the depth test overlay in RenderDoc. I won't go too deep into how you get started with RenderDoc, but there's some documentation and videos about this, so it's really, really nice. And by using depth test, you can sort of see these boxes, because of course the queries are using boxes, not the actual geometry. To see like with the green pixels that have passed the depth test, so they would be visible, and then the red pixels are not visible, so they are occluded by other geometry in the depth buffer. So there's always a pre-pass where only the depth is being rendered, and then based on that, it starts checking the occlusion queries and seeing, okay, is this object potentially visible or not? And with this, we can very easily find wasteful queries. So there might be a ton of really tiny, completely black or completely red, sorry, boxes far off in the distance, and that would indicate we're wasting occlusion query time by doing these tiny queries that are never going to be never going to succeed, or even if they do succeed, they do have green pixels. They still have a problem that they're not going to be contributing all that much to the frame. So one way around this, or one first optimization you could do, is distance culling. You can set on primitive components, you can set a min and max draw distance. Which is super useful for things like light cones, fog volumes, or blueprint components on maybe on your character or other gameplay actors. But of course, it's really tedious to set this on everything manually. So there's also distance cull volumes. And what this does is it maps the size with a cull distance. And so maybe your object size is 25, and you call it after the 2,000 units, you call it, and you just stop rendering that object. That is super useful as it reduces a lot of the load on occlusion queries. And in order to profile this, you can again use stat init views or show flag.distance called primitives 1. Setting that will actually forcefully render them anyway. And so you within your stat init views, you can also see the difference, like how much cost is that adding, or how many more queries is that not adding that we're force rendering it anyway. Here's an example of using min and max draw distance. So here we have light cones in a hallway, and we're using shader complexity visualization to show the pixel overdraw. And then we have the distance cull fade, which is a node inside your material, which is really cool because that will blend between 0 and 1 and 1 and 0 when it pops in and out of that min and max draw distance threshold. So that can really help you reduce the popping effect. Otherwise, it will just pop in and out, and that might be a little jarring. This helps it a little bit by blending it in still pretty rapidly, so you might still see it, but it's much more smooth this way. And in this visualization, you can see the white pixels are really awful. They have massive overdraw, so it can really affect performance. And on the bottom screenshot, you can see that we have significantly reduced it by both using the min draw distance to something so that the biggest light cones also get culled, because you might want to fade them out anyway, because they just be a big bright blur over your screen when they're so close. And really far away ones also won't contribute that much to the frame, so we're skipping them as well. And then to verify that your occlusion, all your occlusion setup is actually working, freeze rendering command is useful to like stop doing those queries and checks, and actually with then semicolon, you can fly with the debug camera, fly around. You can still walk around as well, by the way, but you can fly around to see if there's things maybe behind the object that were still being rendered that are somehow not occluding, or maybe there's this giant mountain that should be off screen, but is somehow still rendering, probably because the bounds are just really large, because there are some geometry sticking underneath the terrain that you didn't notice. So this is a nice way to verify that it's actually working as intended. Then another really easy but manual work optimization is light culling. There is a built-in screen size culling that's not really strict, and probably shouldn't be too strict, because it will start popping those lights in and out. But once your light gets small enough on screen, it will already stop rendering it. But we can call this much earlier on a case-by-case basis. For that, we have the max draw distance and max distance fade range on those lights, on point lights and spotlights, and also on area lights. And the max, the fade range here really makes it blend in and out properly. So then it prevents the popping. So you might set your max draw distance, I don't know, to something like 3,000 units, and then like 750 or 1,000 units to fade it in. So once you're outside of that total range plus the fade range, it no longer adds any cost to your scene because now it's properly culled. So make sure you use this without the player noticing that lights are actually being blended in, but this can help really reduce shadow costs and light projection costs on a lot of lights. And in order to visualize this, you have like show in your viewport, like show like light complexity and the stationary light overlap. And also the toggle light with using a name or a partial name. So you could also just type in toggle light, point light, and then it will disable all the point lights, which can be useful if you have a particular light. You just want to toggle it, see what the impact is on the current frame. Then level streaming, another really nice feature. Will still be relevant in Unreal Engine 5, even though there's a lot of things changing with Unreal 5 rendering. This is great actually for a number of reasons that I'll go into in a little bit. But the way we can do this is by using streaming volumes, or we just manually unload and load those streaming levels. It's important to note that they're camera location based. So if you have a third-person camera that like has a pretty large distance to the character, be mindful of that, because your camera might suddenly stick through a door or like be very close to some volume and then suddenly start loading this volume behind that door, even though you're not supposed to yet. Or with cinematic shots, you might have this wide angle shot that looks awesome, but suddenly your camera is in a different location in the level, and so that might affect the level streaming volume as well. You cannot combine both the volumes and manually loading, unloading on a specific sublevel, but you can mix and match between sublevels. So for example, one sublevel, you just use it with streaming volumes, and the other sublevel, you manually do it based on some trigger volume, based on some game logic, based on a cinematic or something like that. In order to profile this, like what is being loaded and how much time they're taking, in stat levels will be really helpful in order to see like in red which is loaded, or green which is currently loaded, red is not loaded. And then we have load times at dump reports, which will output again to the log a bunch of information like what was the individual asset loading times for each of them. Again, Unreal Insights is super useful here with like load time and file categories. And then for the bookmarks, we have the load levels when they start and end is being shown in the garbage collection, because it's streaming in and out a lot of these levels constantly will cause like a lot of objects being destroyed. So you have to be mindful of your garbage collection and be sure that that's not going to be hitching. Then for performance impacts, it really helps with the initial load time, because a lot of the levels don't need to be loaded immediately. You can sort of like delay and load them in later. Occlusion cost is a massive one, because even when you load a level, you might not have to make them visible immediately. You can just load them and keep them invisible, which is one of the options with loads not visible, or just load, and when it hasn't been loaded in before, it will only load and not make it visible yet. And that can really help with occlusion costs, because they don't actually exist in level yet. So that can be a big win. And then of course for memory, if you don't have them loaded yet, you can still again get a lot of memory, because by the time you might reach that level streaming point, you might have already unloaded some other level streaming volumes behind you. Just a quick note, keep it in mind early for your level design, because it might really influence how your levels are set up with line of sights, like natural corridors and points of no return, all the classic examples. But also it makes the job a lot easier once you actually have to get into level streaming, if things have already been considered for level streaming. So we have animation fastpath. Fastpath is really nice because it allows us to run a faster path on the animation nodes that don't have to call into the Blueprint virtual machine, and rather can use the fastpath for animation. But in order to do that, you have to move all your computations out of AnimGraph and into EventGraph. In order to know what you need to change, you can just enable warn about Blueprint usage in the class settings of your animation blueprint. And this will warn you about any violations of that. And a violation won't fail, it won't crash or anything. It will just tell you like, well, we're using the slow path now, so you're out of luck. And the one downside is you have to move it into event graph, so your logic is a little bit more removed from the M graph where you're actually using the data. And any computation, like even having a variable multiplying it by 2, that's a computation. So that will no longer be able to use the fast path on that node that you're plugging it into. Same with select nodes or any kind of thing that's not just getting the variable is going to be considered a warning. But this can really significantly improve your animation performance because it can do things more multi-threaded and don't have to run the slower blueprint path. Another one, some animation quick wins, just some rapid fire things to look into. Update rate optimization, URO, for distant skeletal meshes. This can be really nice because for distant meshes, you don't always have to tick the animation super precise every frame. You can skip some frames. This is a checkbox and something you can configure in the skeletal mesh individually, which can be very helpful if you have a lot of skeletal meshes at once on your screen. That might be not all super relevant at the same time. Then a visibility-based animatic option. This is another one that I think is quite refreshes and updates every frame, or even if it's not necessarily being rendered, because that's the option that will definitely work, but it's not the most optimal option. So we can use only tick pose when rendered, which will reduce the amount of load on all your skeletal meshes when they are not necessarily relevant for you currently. So you can set that in the individual skeletal mesh, but there's also a configuration option, and then you can still override it in your individual components in order to make some easy optimizations there. Then we have some more booleans just to look into for you. Like render a static is really nice because that will render a skeletal mesh as if it was a static mesh. So we use the reference pose for that. This can be useful if you have things in the world like weapons, for example, or other things that actually have a good reference pose. Like characters might not have a good reference pose; they look T-posing. But this can further reduce the cost because, again, if it's being rendered as static, it doesn't have to update it in the game thread and then push it into the render thread and then the GPU in the same way as with a static mesh. It's just a cheaper path. Pause anims and no skeletal update can again be useful if you have things that need to exist but don't necessarily need to update. You can manually set this. This might be a good one to plug into your significance manager based on some distance or certain conditions. And another thing I wanted to point out is animation compression library. This is not built into the engine yet, hopefully in the future. It's made by Nicholas Frechette, and it has been super great for the games we've been working with. Is that, for example, one of the things is the compression speed up is massive. It's literally been at least 50 times faster, according to his own measurements, like 56 times faster. And it really makes your compression go from minutes to seconds. So this is just a really nice day-to-day workflow improvement, especially if you have a very animation-heavy game. Decompression speed, massively faster, which is super nice for your load times, and then memory size and for streaming as well. And then memory size was cut in half for our game as well, which is super great because we were really memory constrained. It also reduces the disk space size, but I haven't really measured that one in particular. But the memory size was pretty significant, and that was the most interesting one that we really needed. And it's used by Fortnite and other AAA titles, so it's not like an experimental plugin at all or anything like that. So eventually, hopefully built in Unreal Engine 5, we'll see. Another thing I just wanted to point out, without going too deep into it, is the Oodle data and Oodle texture plugins. This came in pretty late in Unreal Engine 4, but it's super useful because Oodle data is part of the packaging process where it will compress your assets to be significantly smaller than the default compression. And then Oodle texture is specifically for the texture data. So what it can do is it can use RDO, rate distortion optimization, to significantly improve texture compression by up to something like 50% or something crazy, with very minimal differences in texture quality. And you can really crank that up a lot more. The defaults are pretty lenient, so that they just definitely look really great and still have big gains without really crunching the textures too much. It does take longer to compress, so by default, as you can also see in that screenshot that hopefully is readable, enable an editor, like the fourth line or something is enabled or is disabled by default, so it's not going to be compressed or not going to be used by default in the editor. But if you were, because it is meaningfully slower than the default compression. And then just to keep it short, like RDO that works with Oodle data, and it's by preparing the data for it. So you still need Oodle data in order to really benefit from Oodle texture, but because it just shuffles around the data to be more compressible. There's more information on the documentation as well, and some really cool blog posts from the guys at Oodle or that made Oodle. Definitely worthwhile to look into. It has significantly improved the package size and also a little bit of load times. Once the texture is in memory, there isn't really any difference. That's not what this does. It is really about being much smaller on disk and having a much faster loading path. Another one I quickly wanted to point out, CPU and GPU benchmark, the synth bench. It's a nice little tool in order to run a quick benchmark when the player first launched the game. And it will give you a guideline of the CPU and GPU capabilities. And this, of course, is mostly useful for dynamic platforms such as PC, because they will have a dynamic result and with the baseline being 100, like anything under 100 being like below average speed. So you might have to scale down, going away from Epic, for example, and going to like lower medium spec. And you can use the CPU multipliers and GPU multipliers to easily like tune based on your specific game. So if your game is very GPU intense, you might use a lower multiplier so that the scalability throttles down sooner. I again have a blog post about this to go into a little bit, and it references some more documents and more videos to really know how to implement this. But it's going to be quite nice to have some base level scalability options set on your PC so that your user doesn't run everything on Epic and then has 10 FPS and has to go manually figure out like what is some decent options for migrate. Again, another one I really have to be short about this is like shadow proxies. This is a bit of a destructive workflow, but it can be really nice if you have a lot of modular buildings, a lot of modular geometry in your world, because it can merge your assets merge your geometry into a single low poly silhouette mesh for your shadow rendering. And then you just disable render main mask on that object, and you disable shadows on all those modular pieces. This can have significant benefit for your shadow rendering potentially. It is a little bit of a destructive workflow. It's not, in that sense, it's not great to do it while you're still iterating on the level. But what I'm really hoping for with Unreal 5 geometry script is that maybe we can automate this a lot more. This is definitely something I would like to try out in the future. Then shadow size map is another nice tool to inspect the disk and memory size of assets, and you can really easily find unexpected large references or bloated content. Like maybe there's some texture that you're not even expected to be referenced by your player character through hard casts and other odd references. Somehow you're loading in half your game. This gives you really good insight into what is happening and why, or like at least what is all being referenced and being loaded in based on some blueprint or some sub-levels, and it gives you some quick opportunities to find ways to like which asset is the problematic one and can be optimized. Another nice one, statistics window. It stats on the current level. There's a bunch of categories. The main one has the main what I use is the primitive stats and the texture stats, and that will give you a nice insight into which assets are being used in your level, which textures are being used in your level. And with using shift-click, you can have a secondary sort, which is really nice because that maybe you can sort by count and then by triangles or by size. And then you can find assets that are really large in memory footprint, but are maybe only used once. You might have a bunch of different barrel variations or rocks or something, and that variation is only used once, but it still uses use of the full memory of that, right? So this can give you some easy insights into maybe we should replace that asset with another rock variation that we already were using. And then to close it off, some other useful commands that I wasn't able to put into the other slides. Toggle force default material. This will actually force rendering of the default material, which is really nice because that has a big influence on your base pass. And you can really see just how much your shaders and switching shaders and having all of these instructions has an influence on your base pass. Dump hitches can be nice in order to figure out when a hitch has occurred. It will give you sort of like a stack trace, like what was the expensive function that might have caused this. And then finally, stat none, because we've been using so many of these stat categories. If you just type stat none, it will clear all the categories on screen, which can save you a lot of time instead of having to type all those categories again to disable them. And then finally, more of a niche option like Art Force LV Shadow. This can be especially useful again for the older or like the less capable platforms, because this forces a lower LOD to be used, even if the object is nearby the player, for like cascaded shadow maps or general shadow rendering. And that can significantly reduce not the draw calls, but the triangle counts being used. So in certain scenes that we tested this in, we had like more than 1 million triangles reduction on a not even that significantly high poly scene by just using a higher blood shadow. Of course, this might change the silhouette of your geometry of your shadows a little bit to make sure you have decent LV setup, and this might change for within that night. So we'll see how that goes. So that was my talk. Thank you for your time. I don't think there's that much time for questions, but let's see.
Don't worry, there'll still be time for questions. Thank you for that. It's a fantastic talk. Lots and lots of great details in there. It's good. In fact, I mean, there's a lot of things. Sorry?
Now I can hear you.
Oh, you can. Are we good?
Yeah.
Great. All I was saying was it was a great talk and lots of great details in there. There's a ton of details. There seems to be a lot of stuff in there to remember, lots of different things in there. Oh, Sasha's lost his hat.
Sorry.
So yeah, lots of things to remember and everything. How do you sort of recommend knowing what to look for? Because there's lots of things covering lots of different areas there. How do you know where to go to look for?
Yeah, that's a great question. I think one of the ways is, well, the documentation does have a lot of this stuff listed. It just might be difficult to find. There's also some nice blog posts throughout the internet that have a lot of this information available. Other talks from previous years on RoofFest, for example, that's where I got a lot of my information from. All of that wasn't included here because it was already in another talk. And a lot of it is just really trying. I think especially early on when we weren't really sure what to do, we were just browsing the details panel of these objects and seeing like, okay, what checkboxes are available on these skeletal meshes? What can we start playing with? So yeah, that's really been a way to just experiment. And honestly, for me, it's already been like many years that I've been sort of like dealing with this. So slowly over time, also by being on Twitter, like people like Chris Murphy always have these great tips that you're like, that existed? Wait a second. And there's always these things happening. So just sort of like being in a community really helps, and just experimenting. That's kind of like how I've had to learn it. And of course, there's documentation available.
Mm-hmm. And I guess coming at it from a slightly different angle, though, how do you know how to apply this stuff? Which things should you apply first? Because this is covering lots of different things, like animation, graphics, physics, and so on. How do you know then which thing you should be tweaking next?
Right. Yeah. I guess that's where really the profiling comes in. So you have the Unreal Insights and you have that stat unit graph that I showed at the very start. That's going to give you some idea of where your bottleneck might be. So that's really where you should be focusing on. It doesn't make sense to do those game thread optimizations on your game objects if you're not game thread bottlenecked, because it's not going to give you any frame rate at that time. So make sure you work on your bottleneck first. And this can, of course, be, take a little bit of time of really understanding what is run where, but that's where, of course, Unreal Insight really comes in, because you can see the individual threads, like you can see the game thread, render thread, and then the GPU. So you can sort of see based on those categories, okay, actually the skeletal mesh is being updated in the render thread here. So maybe we can start looking there what we can optimize.
Cool. Alex, do you have any questions?
Yeah, I'm just sorry in advance. The sun has sunsetted and I wasn't prepared for it, and my light just can't work through. So we have actually a question from your student, Tom.
Okay.
I want to know why the cooling is having so bad performance. Does frame pacing affect it? Hardware occlusion cooling queries are the cause of making the GPU so busy? Or is the phone GPU sleeping for so long?
So the question was about why occlusion queries are so slow.
Practically, yeah.
Right. Well, in the case that I was showing is it just has to do a lot of queries, and then it has to get them back in the next frame from the GPU. So of course, getting things from the GPU isn't so fast, but it's just a lot of objects to consider, and so that's really why you want to help it out. You know, we know a lot better than the GPU what we want to render, especially if we have things like level streaming set up. We know, like, okay, this entire interior is not going to be relevant for a while, so just make it invisible for now, so that the GPU, which is not smart, it's just really fast, doesn't have to consider all those objects anymore. Because it could be thousands of occlusion queries, and that's just naturally going to be slow because it has to render a simple box, but then it has to figure out which pixels pass the depth test and which pixels did not pass the depth test. So that's takes some time to figure out. I hope that answers the question, if I understood it correctly.
I hope so as well.
All right.
The very last question from me, like, how do you figure out that the game actually needs the optimization? I mean, the thing is that you can run for so long, and at some point you actually like miss the optimization that was like tech debt that we made for long ago. So is there an option to have like a per stat for CI/CD and statistics of the performance of your game? Oh well.
Yeah. So there are ways. I mean, there's not, from what I know, it's not like super built in to have this automated process. But again, that's more of like a complicated system set up for yourself, where you might just run the game, use a command to like jump to some camera bookmark, and then do a quick profile GPU, or run some command to dump the profiling stats to a file and then read that out. That does require some manual work. That's definitely something I would like to explore, especially now with like the editor scripting getting like much better all the time. But there's not really a really great option to have that dumped out daily through the continuous integration system. But there are ways to manually set that up. In some projects, you just have a big QA team that are actually giving you this performance statistics every week, because they just run through the game and they just dump you the information. So like, well, the game's actually 10% slower now on the CPU, but of course that's a luxury. So that's something definitely not super built in that I would like to explore, because that would be super useful to have an easy way for people to see, like, over time, our game got actually 10% more expensive in animation, 20% or twice as expensive suddenly. What happened in the last week in terms of commits? So yeah, that's kind of like where it's at right now.
All right, thank you.
All right.
I think then we have one last question from the chat, actually. It says, lots of these optimizations are batch-oriented, general settings for lots of assets. Given this, how do you approach growing numbers of uniquely adjusted settings on individual assets in old scenes?
Yeah, that's a great suggestion. Well, of course, you can easily select based on class or based on object type. So you can easily like batch select those objects and then see, like, is there any object that is still using an old setting, and just override it. I guess that is one way to do it. And perhaps diving deeper into editor scripting might be a really nice way to refresh, or to even use, maybe you can create your own map check errors by overriding functions such as check for errors, I think it's called. That's existing actors, you can override those. And then maybe verify some custom information, like saying, okay, well, if it's this object, or the object is this size, maybe we never want shadows to be set. So unless we specifically have an override for that. So that might help. But I think especially just batch selecting in the editor, that's kind of like the easiest, most low-tech way to do this.
Okay, cool, thanks. I think that's pretty much all we've got time for then. Will your slides be available on your blog by any chance?
Yes, I'll probably refine them a little bit, and I'll probably turn it into a blog post.
That would be fantastic. That's great. Okay, well, thank you very much for your session there. That was brilliant, and I think we'll move on to our next speaker. So thank you very much. Okay, I think it's time now to introduce Felix, who's going to be talking to us today about Unity and Unity packages. Hey, Felix, how are you doing?
Hey, I'm good. How are you?
Doing well, thank you very much. Enjoying ourselves immensely. So, got to ask you the question. It's what was the first game you created?
First game I created was as a student in a small team, incredibly overambitious. We immediately started with a multiplayer mobile game series, of course, as the first thing to try as students. And that actually worked pretty well. Like we got super far. We had like multiple little games that were actually like networked and doing things with each other. So it went surprisingly well for how ambitious it was.
Nice one. Hopefully you can you still got it somewhere to check back on. Right then, are you ready to give us your session? Should we share your screen?
Mm-hmm.
And we'll leave you to it then. And yeah, enjoy. Thank you very much.
Good luck.
Okay, yeah, thanks. Yeah, I'm Felix, and today I'm going to talk about Unity packages and our path at Needle from like trying to figure out what these new things are that have popped up in the editor at a random point in time, to building entire projects around them and leveraging to their fullest, kind of. And it's an interesting topic that I wanted to talk about for a long time now, because there's so much confusion and misunderstandings, even in like teams at Unity and teams using Unity, on what these packages are good for and not good for and how to use them. And so I hope we can uncover some of that today. It's going to be quite a whirlwind. I have a lot of topics I want to cover. So we're going to get started. So first, as a little bit of overview, besides running Needle, I'm also running a brand agency, Prefrontal Cortex. And so this is where actually a lot of the need for packages first arose. So we saw them appear in the editor in Unity 2018 as a new way to manage and structure code, and immediately jumped on that as a solution for copy pasting things between projects, which was pretty much the standard at the time for reusing code, either that or submodules, like both have their problems. By now, both Needle and Prefrontal Cortex have their own package registries, similar to what you're using when you're consuming packages from Unity. There's about 40 on the PFC registry. There's about 23 on the Needle registry. For comparison, there's like 250 plus packages on Unity's registry, at least the ones that are public. And a lot of people are by now aware of OpenUPM, which is another registry for hosting open source stuff, where you have like 1,800 plus packages by now from various people. And so that just as an overview, so like everything at our companies is now structured around packages. Like there's no way we're copy pasting things from one project to another anymore. And to show how that what that all means and how small teams can manage packages in this way, we're going to do a little bit of a refresher, starting from scratch, from what packages are and so on, and then gradually going into more complicated levels on what packages can do and how they work. So on a very basic level, what has changed for a lot of people is a new folder appeared at some point. So in Unity 2017, if you have an empty project, looked like this. You have your scene, you have your stuff, everything's there. So basically, all you do is in your project folder or is in core Unity. And in 2018, that changed. Like Unity started modularizing some of their core and putting things into packages. And that's interesting. Like that's how a lot of people noticed it first. There's now an assets folder and a packages folder, and that was about it at this point in time. Not a lot of documentation and so on. This has changed a bit But still, there's lots of untapped potential, I would say, that I want to cover here. From then, there have been like a couple design changes and so on. And nowadays, this is what you see. So by default, there's more packages. So more of Unity's code has actually become modular and accessible in this way. And it's also Pacman has changed. And that brings us to kind of level 2. So we have packages. How do we manage them? There's a package manager by Unity. And initially, it looked like this. Gradually got more refined, got more features. A lot of you know this, so I'm not going to cover it a lot. One recent interesting addition is features. So you can have feature sets, basically packages that are in themselves pulling in more other packages. And you can make your own. So this is another interesting thing for studios and larger organizations that want to always bring a number of packages into a project. And there's more changes, like this is fresh 2023.1, where you can see a little bit more about which packages have dependencies and so on. And yeah, I'm going to cover this a bit more in later slides. But yeah, that's our package manager. It's relatively minimal, and it's clearly designed for consuming packages, basically for installing them from Unity's registry. So how does this look for a specific project? So you always have a project manifest, which means that in every Unity project you have nowadays, there is a packages folder. In that you have a manifest JSON, and in that manifest JSON you have the identifiers and versions of packages that you're using. That's not the only thing there is. There's also a package log, which is pretty important. So please make sure you have this as well in source control. Like I've seen companies exclude that and then wonder why things break. When Unity kind of tries to make sense of all the packages in your project, it resolves which versions can coexist at the same time, or which version of a Git package to pull in and so on. And this is all stored in that package log. So it's important. Please keep it. So one interesting concept of packages is the idea that by default they're immutable, which means that when you download a package from Unity's registry, you can't change it. Like you can open those files, you can look at it, you can read that, but you can't start changing it right away because the system will notice that and will reset that package. And the idea is you can bring in packages and you have a given state. But one great thing about packages is that you can make them mutable. That is, you can make them editable and adjust for your own use cases. And one thing where people do that a lot is, for example, the scriptable render pipelines, where you can like take universal render pipeline and make it your own in a specific project. And I'm going to show a quick overview of that. Of how the process looks when you want to actually edit a specific package, because there's also a lot of misinformation around that. On the most basic level, you have your packages. Each of these are immutable, and I'm going to cover why I'm seeing this here a bit differently in a moment. And if we, for example, now want to change something about the timeline package here, we can open that up in the Explorer. And this actually brings us into the project library. Like each project has a library where all the stuff is cached, including packages that you have pulled from a registry. And so what we can do here is we can actually simply grab this version of timeline here and go some folders out and go into packages and drop that here again. And just by doing that, if I focus Unity again, Package Manager is going to pick that up and see, hey, there's a new version of this timeline package that now is mutable. So, and some of our tooling that I'm going to share later is displaying that here. So we see these are all still immutable, and this one is now actually editable. So I could go in here and actually change how timeline work if I have a specific project that requires doing these adjustments. And on a basic level, this is a core difference here between packages that you can't edit and don't want to edit, and a point in time where you decide, I now want to start doing changes to a specific package. And you can go both ways. You can also make a package immutable later on by publishing it again or packing it again. I'm going to cover that in a moment. So we saw a little bit of like, this is how packages look in Unity. This is how you start editing them if you want to. And we're also going to cover a bit on, okay, what if we want to make our own packages? Because obviously that's what I think one of the most interesting aspects of the system is. It allows companies to structure their projects differently and to start putting all of the code that is in various places into reusable pieces. And on the most basic level, what we have on the left here is a complete package. All we need is one folder and one package.json, and then we have our own. So we're going to do that here. We're going to go back into our project. We're heading into this packages folder here. We already have our timeline. And we say we want to make a new one, like my package. And all we need here is basically one package.json. My text editor, large monitors. Here we go. Okay, we need one package.json, and in that we need a name and a version. So there's specific rules how package names and versions work in Unity, which differs a little bit from kind of the parent of that, the Node package manager system. For example, you have versions always in this 3-part system and not in scopes and so on, but that is not that important here right now. On a very basic level, we now have our own package, and all it has is this one file here. It doesn't look nice, so we're gonna adjust its display name here. And so this is already like on a super basic flow, how you make your own. And of course, if you're doing that in production, there's a little bit more to it. Like you will want to have more info in the package.json because that helps people to see what it does, to see who the author is, a description and all kinds of things that package manager can also show back. And even including samples that people can install for your tooling if you put it correctly into the package.json. And as you already saw, my packages in Unity look a little bit different than they do by default, because at some point we started building our own tools for making common operations with packages easier. And common operations means things like, I want to have an understanding of which packages in my project are from which version, or which I can edit and cannot edit. And that becomes more and more important the more you compose your projects from packages. And you can actually install these on your own. Code is not open source yet. We're planning to do that at some point in the future. But the package is already available on our package registry. And I already have that in the project here. And one obvious change, like it's this one here, our package tools. And one obvious change that this does is it displays which of the packages in your project are editable and which are not. That's one thing. What it also does is in Package Manager, it shows the source of packages better. So by default, if you have Package Manager open, you don't quite see which packages come from where. So let me just quickly turn it off here. Oh, not this. Where's my project settings? Oh God, large screen. There we go. 1 second. Here we go. Okay, so this is how Pacman looks by default. So you basically have the versions, you have some state about them, you have at least the author, but you don't see really where's this coming from, which of these are actually part of my code that I want to be able to edit and so on. And this is what our extensions change. They add these tags here. For example, this package comes from Git. This package comes from the Needle registry. The one we just created is an embedded package, same as timeline here. And what it does, and that is for us the main factor for actually being able to maintain our packages and our code well, it adds stuff on the right side here for managing managing the details of a package, being able to quickly jump into the package JSON or editing the changelog, or tools for publishing and for verification and so on. And this is all stuff that I'm not going to go into super deep detail here. You can try it all later on your own. But the gist of it is it makes it super easy to see if you did everything right with your packages. For example, you should always have a changelog that matches the actual version you're releasing and so on, which is something that even Unity's packages sometimes gets wrong and so on. So these are our package tools. So yeah, publishing tools and so on. And from this point, I think it's worth looking a bit more into how this package system works under the hood, because there's a lot of interesting details in that for how you can work with it and modify how things work. Now, on a super basic level, in each editor installation, you have a resources package manager folder, which contains a bunch of things related to packages. And there's, for example, the packages that already come bundled with the editor. And for those of you who have been wondering why like Unity editor installations grow, it feels like exponentially over time, it's because Unity starts adding more and more packages that they're shipping with the editor to keep download times low for users that open things for the first time. So for example, you have 1 GB of 3 different versions of Burst in each editor installation nowadays, because you may need them. And obviously, all of these can be fetched from Unity's registry as well, but seems it was easier to ship them with the editor. What this shows us, and which is an interesting detail, is that you can ship packages as archive files. So this is a TGZ, so a tar gzip file, and it contains an entire package, but you can reference this as something immutable again. So even when it's like one file, you can reference this into projects and you can make your own. So also interesting, one folder inside Package Manager is project templates. So actually the templates that you can install from the Unity Hub are packages in themselves that kind of get unpacked to projects. And you can also modify these and make your own templates, which is something that people have been waiting for a long time from Unity to make happen. But actually, you can already do it, and a lot of companies are doing it for their internal workflows, for like specific setups, bringing their own packages on and so on. And so this is how you can make a package archive and have it be a template for future projects. No, and another detail here is how does Unity actually manage which package versions get shown if you are in the editor and you list, let me just quickly show that. If you list like what packages are actually on Unity's registry and which you can install and so on, where does this list come from and how does Unity know which packages to show in which version? And this is where this fancy file here comes into play. So this is on Unity's registry. It's kind of a special package that contains metadata for these packages are available on the registry. These are searchable. Some are not searchable because they're always installed as dependencies and so on. And yeah, and they make continuously new versions of this for these are kind of the entry points for packages that can be searched. And matching to this, each editor installation contains another list of here's how you map to that and which versions to show for that editor installation. And one thing that's interesting here is that by looking at this list, one can programmatically get a pretty good list of which packages does Unity actually have available. And so one thing we did relatively early on at Needle is making sure that we can look at the various versions of packages better based on this list. Because what happens when you install a new version from Pacman in Unity is it just switches that code on disk. You get a new version of that package, say you're updating your URP from one version to the next. You get something new, you don't really know what has changed and why did Unity update that. There must have been a reason. So usually there's a tiny changelog and something like this. And this is not enough if you're actually working on production projects where you need to modify these packages, but still be able to follow if Unity does bug fixes to say URP and you want to modify this and bring your changes back. So we started this project Mirror, where basically what we're doing is we're looking at this file regularly and check, do we know all these packages? Have new versions appeared for these packages? And if yes, then we're mirroring them to GitHub. And how that looks, oops, can I get that back? And how that looks is that you have an entire GitHub account that's responsible for keeping track of versions of packages. And so basically each and every package that Unity releases on the registry gets mirrored here automatically. And from this, you can dive deeper into the changes, for example, that have been done to them. And I think I have a slide for this here. Like one example is the addressables package that a lot of people are using and modifying in their projects. And if you're just using the one from Unity, then basically Pacman gives you that new blob. Like here's a new version of addressables. Having all of this as versions on GitHub in like GitHub's system of comparing things, looking at changes and so on, opens up this interesting capability. Wrong link here, sorry. Oops. Addressables, I wanted to see. Opens up this interesting capability of, for example, comparing between versions. So I can jump into like this version here and can see this is the changes that have been done. Like this is all just mirrored from what Unity puts in their changelog. So we see like 5th of October was the last update here. We have a specific changelog, but now with Mirror, we can actually go in and see what did actually change between these versions. And this is super helpful for keeping track of, for example, things changing in timeline or things changing in URP or in any package where we've seen a lot of projects that go deep on working with these packages and modifying them for their own needs. So you need to be able to see what has actually changed from version to version to not lose track of that. And so we have, for example, have a bunch of changelog stuff, but then we're getting into changes on there. They have the build target changes or things have changed how errors work, different calculations and so on. And usually you shouldn't have to worry about this. And unfortunately, this is still how Unity sees that. Kind of, you shouldn't have to worry about these things. It's an internal package. You should just consume it. But that's not how reality works for a lot of productions where you need to be able to see what happens and why and adjust it. And often the flow for this is something like you can dive into specific code in a package via a writer and look at like what happens where. And then you can actually check out on Mirror why specific changes have been made or why your code broke now due to a change in Unity's packages. And this is a very nice learning resource, but it's also a crucial part of these modification workflows. Like what we earlier did on just copying in the timeline package is okay if you want to do a quick modification, but it's not great if you want to actually do this in a production where you later might want to update to a newer version of timeline, for example. And so what a lot of people are doing is they're forking from Mirror actually. And so for example, the addressables package alone has been like forked 39 times from here. on people doing their modifications because they want to be able to get the upstream changes from Unity at some point. So that's Mira. It makes things easier for modifying Unity core packages and so on. And actually, one thing I forgot is we do have a Mira integration in our package tools. So if I go into the input system here, there's a direct integration for saying, okay, let's see what has changed here. Like, let's directly compare how the input system changed between these two versions. So basically, after an update, if something is broken, you can take a look at what has actually happened. So this brings us to kind of the next level. We now have a better understanding of this is what packages are, how to modify them, how to move them around. If you're doing this for an organization, you want to be able to publish these packages so that other people can download them again. And the way this works is always through package registries. And basically, if you're interacting with Package Manager, all that happens is that it lists which packages come from specific registries. So like this is what comes from Unity's registry. And there's another field here for my registries, where we now have like all the packages that Needle has online that are compatible with the specific Unity version. And the way this works is that you can have many registries in one project. So it's quite common that you're consuming things, say, from your own registry, from OpenUPM, from Unity, and potentially a couple more, and have specific packages from each of them that you're composing your project of. And so Package Manager allows managing this. Here, it actually all lands in that package manifest file. So everything here is actually something that you can do programmatically, basically in larger pipelines. Let me just show that quickly. So how it looks in the manifest is you have these scoped registries where you have a name, the URL, and scopes. So same thing as in the UI. But actually something that you can modify through tools. For example, you can just write this manifest file from a tool and say, I want to set up a new registry here, or give this to people as a template for starting projects in your organization that should like use specific packages. And there's a number of registries that you can basically readily use. There's your OpenUPM, which I mentioned before, which is an open source registry that now has like 1,500 or more packages. And what's often more interesting for organizations is being able to host your own registry. So for example, we're using Verdaccio, which is actually an NPM, so not directly related to Unity. It's more like a Node.js scoped registry or registry that you can use and set up your own and so on. And this is super easy to get started with. It's as simple as running your own on Glitch. Glitch is a super tiny, is a super useful web service for having tiny Node.js applications. And so with just one click here, we can actually remix our own package registry ready to be used. So let's just have that run for a moment here. And this is also something that we built to make it easier for people to get started with packages and to run or to experiment with registries and see that flow. And of course, later you should definitely put this on your own, either on your own infrastructure or onto something bigger. Like Glitch is a super tiny instance. I wouldn't use this for a large organization. But for experimentation, it's great. So basically, our registry is now already live. Our new one just remixed here, which looks like this. And from here, we could basically add that in Unity, publish packages to it, send it to other people, and they can install packages from there. So great experimentation ground. And yeah, I'll keep these links in the slides, of course, so you can later experiment with this on your own. And so, yeah, maybe one step back here. So if you have your own registry, then of course you need to be able to also publish packages to it. And there's the usual way for doing this is through the command line. So you're able to basically, for example, open up this one in the command line, and then there's an npm command for pushing that to a registry. And there's some helpers for that here as well for publishing. For example, our little package here doesn't have a changelog yet. So we can click this button. Now we have a changelog, and we can make sure to fill that out for what we have done with our package here. So, hey, we have a changelog now. Should also have the right version and so on. Like, there's more conditions to this. But ultimately, you open a command line then and doing something like npm publish to publish it to a registry that you have set up. We won't do this here, but I wanted to point that out. Like, this is one flow, how you can do this. If you're working with OpenUPM or other registries, there's actually Git actions and things like this, where you just push to a specific branch or you tag a release, and OpenUPM is automatically gonna fetch that and make a new release and so on. So multiple approaches to this. But it's relatively simple and well documented, so I'm not going to cover it more here. Oh, 1 second here. One other piece is how do people now install these? So we already saw one approach for installing packages via manually editing details in the package manager. But there's other ways on acquiring packages and putting them into your projects. So one, as shown earlier, is, for example, here, when you want to get this from OpenUPM, there's a way to manually install this, where you, for example, add the right scope. And we can do that quickly here. Oh, wrong one. Close this guy. Get here. So we can say we want OpenUPM, we want specific URL here, and we want a specific scope. And this is enough to basically tell Package Manager on where to look for these packages here. And if we open up Package Manager and go on My Registries, and if we didn't mess anything up, it should be able to pick that up. Why doesn't it? Oh, because we have a super wide. Yeah, that's actually good that this happens. Like, one of the pitfalls when using with packages is that you have to be careful about these scopes. So for example, now our needle registry here kind of has a wider scope. We want to have all needle packages than OpenUPM here, where we just want to have a specific one. And it's one of the cases where you can't fix that in the Pacman UI, but you can fix it in the manifest. So we're going to do that. Basically, we just need to switch these two entries and tell Pacman, please first look on OpenUPM, and then secondly, you can look on the needle registry. Hello. Won't show us. Yeah, there we go. So now you see that basically compilation visualizer here comes from a different registry, which is again something that you wouldn't see in regular package manager, but you can see it through our extensions. And now that we have this set up, we can install that and have our new package from a new registry in our project. And it doesn't actually matter if this registry is the Unity registry or OpenUPM or somewhere else. The flow is always the same. Oh, and now we have this here as an immutable package because we installed it from a registry. So that's the OpenUPM flow. You can also install packages from Git directly via like Git URLs, for example, Unity GLTF or something else, which you can do. I wouldn't generally recommend when working with packages because of these earlier mentioned problems with package resolution. So basically, when you're using a Git or your URL, you're always getting the version that's currently live on that Git repository, at least if you don't specify more information in the path here. And so you can do that. Not going to go into details on it. I would always recommend, if there's a registry version available for a package, do that. Oh, and one more way to install things is as a hybrid package, and it's something I want to briefly cover as well. Hybrid packages are, is it actually the next part here? Let's see, not yet. Hybrid packages are an interesting middle ground between the old world of Unity packages that you still have on the asset store, for example, and the new world of packages on a registry or UPM packages. And what this does is you have a Unity package, but what it actually contains, where's my Unity? Not this one. This one. What it actually contains is a package. So Unity packages are just zip files, essentially, that unpack into your projects. And so we found a way to modify them, like by default, Unity packages only allow you to unpack things into assets. But we found a way to modify that and to actually tell it, hey, this is where I want to unpack. I want to unpack into the packages folder. And what that does is when we're importing this, different layout. When we're importing this, then we're getting a package here that is now mutable and that we just installed from a Unity package. And this is something that we coined hybrid packages, and I think I have a few more slides on this later on. So one more way to install things, and especially useful for the asset store or for other cases where there's no real integration of a registry yet, but you still want to be able to work with packages. Besides this manual workflow of like entering stuff in the package manifest or in Pacman, there's also a package installer service that we've built like years ago now, where you can just construct a URL and tell it to please give me a Unity package that will set up a package in my project. And as an example, we can again download compilation visualizer here. So we're, oh no, why does it try from there? Wrong link. Let's try package tools. Yeah, this one works, okay. And what this does is also via Unity package, but you have an installer. And this installer is doing slightly more things than just copying this in your project. It actually sets up the registry and yeah, Pacman complains and says, or not complains, but tells you, hey, there's a new registry that has been added by someone else, which is what the installer has been doing. And then if we wait a few moments, we should have this here as well. And there we go. So this basically installed the package tools by setting them up as a package from a custom registry, adding that to the manifest and so on. And then the installer removes itself. And we've built this because, as mentioned, you basically always want to have registry packages. You don't want to like just copy things around. But Unity makes the flow too slow. Like for like mass usage of packages across projects, always having to manually do this for new projects is just cumbersome, which is why we have this installer, which is free and open source, and a lot of people are using it. So I think we have some statistics that something like 50,000 package installations or so have been done over that installer in the last years. One thing that's relevant, especially to organizations, is package registries sound nice, but then you realize you don't want everyone to be able to access these packages. And this is the interesting part is, since this is built on top of NPM, like node packages, actually authentication is something that you can do. And of course, people have been building packages to do that for you, to basically manage credentials for registries. And there's a really cool one from Helodi that allows to manage these credentials. And we have a simplified version on our own registry, free to use for people for managing package credentials. And I can again show how this looks. So basically, if we open our project settings, we have a new field credentials here where you can add credentials for a new registry. You can log in, enter your password, and so on. And this makes it possible to use packages as well in corporate environments where you need to protect the stuff. You may have it behind a VPN. You may have it on a public URL like Unity packages work or like Needles packages work. But some of them you want to protect and only make accessible via authentication. And contrary to what the package manager documentation from Unity tells you, it's super easy if you use these kind of helper packages here, which behind the scenes do the right setup so that kind of Node.js Pacman knows which credentials to fetch and what to pass to the server and all that kind of stuff. So actually a solved problem for quite a while, and a number of companies are using this. Okay, I already mentioned hybrid packages quickly from installing them, and as a repeat part of that, hybrid packages are a bridge between the old worlds of Unity packages that are just basically zip files to new UPM packages that can do more. And one thing we realized while working in both of these worlds is that Unity packages can unpack into any folder structure if you bend them a little bit. And UPM packages only require a specific folder structure. And this is also something that we saw a lot of companies adopt for various cases, and that you can even ship things to the asset store. So this is the way, if you nowadays want to ship actual UPM packages to the asset store, and you can do that through that hybrid packages tooling. And in fact, recently, Unity released new versions of the asset store tools that contain this as kind of a hidden functionality that you can activate with a keyword. And basically, we had a lot of discussions. I told them about our approach here, and that we found a way to bend the will of the asset store to allow packages sooner rather than later. And yeah, you can do that. We like some of the Needle packages on the asset store are shipping in this format, which is kind of compromise between this old way of asset store things just randomly unpacking everywhere in your project and the new way of structuring things and modularizing them. Okay, and with this, we're getting into some of the more complex topics. We only have, I think, a few minutes left, so I'm going to show most of this right in Unity on how does this look in practice for more complex projects, and how do you actually work with packages if you have all these setups. And for that, we're going to jump into what I'm calling a package playground. Like basically, it's one project that contains all our packages. And from here, we do testing, like we test that various packages nicely interact with each other, or that they are ready to be used across different Unity versions and so on. Because one crucial aspect, if you're actually going into developing packages and running your own registries and so on, is you should make sure that this is properly tested. So otherwise, people update something from Pacman and things are broken. So you want to always make sure your packages interact nicely with each other, and you want to make sure that they interact nicely with various Unity versions. And I know that in the theories that that Unity usually has about how people are using their editor, everyone has this one project of their game that they're working on for 3 years, and they're never changing the Unity version. And so this shouldn't be necessary. In practice, we've seen companies that have hundreds of Unity projects across all versions. Prefrontal cortex, like my agency, is one example for that. Projects are shorter term. It's not 5-year-long games. It's working on something for weeks or months, and then always starting with a relatively fresh Unity version. And so there it's really important that packages work across various versions of Unity and so on. And how that looks is basically that you have multiple Unity projects. Like all of these here are Unity projects. We're usually putting the version right in the folder name so that we know what is what. And each of these projects references the same packages. And this is pretty cool because it means that you can have multiple instances of Unity open that all use the same underlying package code. And the way this works is that in your manifest, you can actually have file references. So basically, instead of referencing packages from a registry or just locally, you can tell it, hey, this package comes from a specific place on disk, use that. And that immediately allows you to compose projects of the same packages. And it's not a cache, so it's not the same as what Unity does with their library on like copying an immutable package into it. It's actually the version of these files on disk. And what that allows to do is basically having these multiple versions open. Let me just open a few more here, or maybe this one. Oh, here we go. And you can basically have multiple instances of Unity open, multiple instances of Writer if you must have, and working on the same, very much same code on disk across these various projects. And that makes things that are traditionally very hard suddenly easy. So for example, adding the right if-defs to your projects to ensure that they work across versions, or ensuring that a specific package works with one version of URP and another, and all these kind of things suddenly become a lot easier to maintain because you're effectively working simultaneously on all of them at the same time. And in the beginning, this takes a bit of getting used to on, like, as I'm doing here, managing multiple instances of Unity at the same time, ensuring that this all checks out. But ultimately, this is a really great workflow on structuring your packages in this way, and on just referencing them into multiple Unity projects. And usually, like, we have a little bit different structures for different packages, but usually this is also reflected in source control. Like, for example, this is our main entry point for the maintenance of these packages. All the actual packages are submodules here, and the projects are managed in this wrapper here. And often some of these packages in themselves have their own test projects. Like, for example, Shader Graph Markdown is a package that's on GitHub and open source. But there's also a test project for it that has, again, this same structure of various individual Unity projects with different feature sets. For example, for something like Shader Graph Markdown, it's important that it works in URP, it works in built-in, and needs to work in projects that have both of these, and so on. And so there's even more permutations to keep track of, and it would be impossible or very hard to always change this in one project. Like, say you only have one project, and you want to test all these changes, you're continuously removing HDRP, adding URP, and all these kind of things. So this becomes old very fast. And so instead, this compositional approach just allows you to say, here's the source code of this package, and I'm using that code across all these various Unity projects. So yeah, here was an overview of that. The way this works on a code level is you have your if-defs, you have assembly definition files. I'm not going to go into those here, but basically you can make your code work for various breaking changes in other packages, in Unity core, and so on, by being careful about what you're adding there in terms of keywords and so on. Yeah, so this is one part of project composition. The other part is how you're actually working with this in productions, like when you're working on a game. And what we found, what actually has happened for a lot of the projects that we're working on, is the assets folder, like the good old assets folder that everything has happened in over the years, is becoming less and less important. Everything happens in packages because this composition approach is so strong for workflows. For example, even in projects that for example, that have art assets and code assets, we often separate those into separate packages and just say, okay, there's one package that has the art assets and one package that has the code for a specific project. Even if those are not on a registry, they're just in your regular repository, they're regularly on disk, they're just in a different folder, same as we did earlier with that my package, like our simple one. And this allows you, for example, to have thin Unity projects that wrap around these packages. So what you can do, for example, is you have your full project where you say, this is where art and code come together. But you also have a continuous integration project that doesn't have the art assets. It only has the code packages. So, and obviously the project itself will not work if you don't have all those art assets, but you can very well run all your unit tests, or you can run specific smaller scoped scenes and all that kind of stuff. And you're not getting all the asset import times and so on. And on some project, we've seen this as far stretched as like artists are working in one Unity project and developers are mostly working in another one. But since they're sharing packages and sharing prefabs and all that kind of stuff, everything keeps working and you're not getting heavy import times because the artists have added like 3 gigabytes of textures. The artists are not getting immediate like compile errors and so on if the developers have messed something up. So you separate this more by moving it into these separate packages. And this is also cool because when you're running into problems with like a Unity subsystem or a specific platform or whatever, what we often end up doing is we're spinning up a new project, just adding the packages that we suspect are responsible for producing that issue and testing with that. And that cuts down iteration times. It makes it easier to actually like find a problem, pinpoint where it comes from, and so on. And yeah, that's the other side, like 2 parts of composition here. One is composition of these kind of test projects where you say you want to have your packages in various versions of Unity. And the other is composition in production projects where you usually have the same Unity version for everything, but you're combining packages differently depending on what these thin projects do. And the assets folder in that case mostly becomes a place for project-specific configuration files, like XR setup or specific scriptable objects that control how things behave, or project IDs and all that kind of stuff. So these stay in the assets folder. But by now, for even super large projects, we basically have empty assets folders without code, without assets, without anything but these configurations. Yeah, and from here on, I have to choose in the few minutes I have left, because many topics I could go into. One thing I want to quickly show, I think, is something about dependencies. So if you're working with packages, then ultimately you're going to get at a point where you have dependencies between these packages. And usually that's called a root package or a leaf package, depending on, does this package have other packages that depend on it? And this is always an interesting design choice, especially if you're getting started bringing your company's code to a package registry, on how much or how long do the chains of dependencies get for stuff, and how much do you try to have kind of a shallow hierarchy of things. And it's an ongoing challenge also for Unity's own like package system. So there was a point in time when there were relatively not careful enough with that, and there were packages springing up left and right. And so in some areas, they have a dependency problem, basically, where there's so many dependencies that it gets hard to change, to do any meaningful changes. Like you would have to do changes across the board to do that. And this is one of the reasons why they, for example, have started moving the graphics code back into the core of Unity and not as packages on a registry anymore, because they're always changing those in lockstep, and that gives them less dependency headache. And what we tried as an experiment quite a while ago is visualizing those dependency structures. And I can share an interesting example that maybe gives some insight into development delays of some of the systems that Unity has been working on in recent years. Okay, so this is a graph of dependencies, and it's basically a tool that we've been building just for seeing how packages are connected to each other. And what you can see here, I mean, it's all tiny, but for example, this is entities. We're in the graph for 2019.4 now, where basically Unity was still saying, okay, entities is right around the corner. It's going to release any minute now. And so there's an interesting visual difference between the upper part of this graph here, which looks super messy, like there's so many connections going on, and the lower part of the graph here. And the difference is that the upper part is everything related to entities and everything related to bursts and jobs and these kind of things, with all the various things that have appeared about Tiny, about dots runtime, about hybrid rendering, and all that kind of stuff. So it's super messy. And this was already obvious from just looking at the dependencies that this is nowhere ready for production. Basically, whenever you see multiple versions of something in these stacks here, it means that across these packages, there's no understanding of what the actual shared dependency is. So basically, when you're pulling in multiple projects, you suddenly end up with packages that were tested against jobs 2.4 and packages that were tested against jobs 2.7 and so on. And so all of these have different dependencies. So someone didn't quite get a hold of like keeping all these threads together and keeping the dependencies in check. In the old Unity world, basically, that all looks more orderly. You have pretty short chains. You have not as many overbookings as what we call them on how many versions of this does it need to be tested against at the same time, and so on. So everything looks a lot more orderly. And if you compare that with 2021, I think this is just a random 2021 too. Here they made the hard decision to postpone entities officially and remove it from Package Manager entirely, to give them more time on fleshing them out. And I think now in like end of 2022 cycle, 2022 cycle or 2023 cycle, we're seeing the first fruits of this on a more ordered version of these packages coming back. Like lots of stuff has moved into the core. Someone probably went back to the drawing board about dependencies and so on. And you get more orderly hierarchies on how things depend on each other. And I think while this is mostly a curious example, I think it's always interesting to look at packages if you are structuring them for an organization on these kind of dependency chains. So how do you want this to look in the end, actually? Like, do you want long chains or do you want shallow chains? Do you want to make sure your packages support a wide range of other dependencies, or do you want to make sure they mostly work with individual ones? And there's no like one size fits all rule to this. So it's something that you have to figure out for your specific organization. Like, and it depends on things like how many simultaneous Unity versions do you need to support and so on. Yeah, and with this, I think we went from super simple examples on how packages work and how they look in Pacman and so on, all the way to complex dependency change and looking at how messed up this entire entity system was in 2019. Yeah, quite right, as promised. And yeah, feel free to reach out to me or to Needle in general if you are planning to work with packages, if you want to use some of our tools more. A lot of it is open source, other parts are not. I would have had more things here, but we're out of time. And so I'll have to save that for a later talk.
Yeah, thank you, Felix. That was actually great. I have to say that you probably inspired many people in the stream, especially with the later tool. It really looked great and fantastic. And I have to say, being a C++ developer, I feel envy here. Like for every ecosystem that have a decent package managers, I'm like, oh, come on, when we can have that as well. I mean, like, yeah, that looks fantastic. To me, it looks like a dream, maybe from some other life. Okay, so I think we have some questions. So Matt and Alex, maybe you can.
Yeah, I'm going to jump in there because I thought that was can you hear me? Sorry. Yeah, great. Yeah, I thought it was fantastic. Lots of great tips in there for working with packages, and they are much more powerful than I realized as well. Actually, you can do a whole lot more than you realize based on what sort of Unity gives you and stuff. Yeah. Some really cool tools in there as well. So I like the highlighting in the project view, which showed you which packages were mutable and immutable. So a very simple feature, but really, really useful and everything. But the thing we got the most comments for at the end was the graphs you were showing at the end. Is that available? Is the package diagram tool available?
I can make that available. Like right now, it's relatively old tooling, was an old experiment basically, and I never got around to just releasing it. But I can do that. Like there's nothing secret in there that just like parses package dependencies and shows them with GraphView. So yeah, I'll make sure to upload that somewhere and tweet about it.
I think that would be appreciated, yeah, because it's very effective. And I think the demo you showed of it with the entities versions is very powerful as well, actually. It shows how things have changed over time there and how to manage your dependencies effectively there. Very cool. Yeah, I like that. Anyway, so yes, if you could share that, that would be really cool. Mm-hmm. The other question I'd got was a question about the hybrid packages as well. So they look kind of useful, but I'm not quite sure when you would want to use them as opposed to packages. Why would you want to convert a Unity package into a new style UPM package?
So one reason there is we're doing that, for example, whenever we're downloading something from the asset store. The asset store is kind of this old world by now where you're cluttering your project. Like we all know that you download something from the asset store and it's kind of a gift box of where will this tool unpack in my project and what kind of havoc will it wreak. And I look very much forward to a future where everything is neatly structured in packages that don't mess with each other. And the hybrid packages approach is kind of a stepping stone in that direction. Like originally, we really built it to be able to release UPM packages on the asset store because Unity has been saying that they want to get this like production ready for, I don't know, 5 years, like since packages exist now. And we got impatient and found this interesting workaround. And the cool thing is that they adopted it and now make that, like, there was quite a bit of discussion on, hey, you really found a problem, or you could consider it a bug that like Unity packages allow you doing that, unpacking into different folders than they were intended for. but it turns out to be like super powerful for structuring like this in this way. And so this is really the gist of it. Like, it was originally intended for shipping things on the asset store while packages are not fully ready there. But we've seen that companies have adopted this as well, because it makes it relatively easy to, if you don't have a registry, for example, to ship packages to people by just giving them a file. Like, you give them a Unity package and they can unpack that and they have a new version of something. And it's easier than a lot of the alternatives. Like, you don't need to send someone a zip file anymore and so on. And it's still cleanly put in one place. It has a clean version. You can be sure that you're not introducing unwanted files and moving things all around. So lots of structural improvements there. But if you have the choice, I would always recommend put things on your own registry, make them immutable, and maintain them properly.
As UPM packages.
Yes.
Right. Yeah. So we had another question then about auth. So on the first, well, we had two questions really. So we had since Unity does their authentication at the license and seat level before the package manager, how are you approaching auth for private registries? And then you showed a solution there, so you can add authentication. But what was the authentication scheme being used there? Is that JWT or what? What are you using?
Yeah, this since this is based on, like, we're not inventing the wheel there or anything. Like, this is what NPM is doing for authentication against registries. And all these packages in Unity do is add a nice interface so that you're able to like log into it and use credentials. And so this works with JWT if the registry is set up to do authentication with that. Like, other registries are set up to just do simple like Bureau token authentication. So it does that. So it really depends on how you're setting this up.
Okay.
And then also, like, depending on how it works on your registry, you can also do that differently. For example, at the Needle registry, we allow you logging in with your GitHub account, and then you get your token. And basically, in the configuration of the registry, you can say, okay, which GitHub organizations do have access to like which package, or which accounts have access, so you can fine-grained manage who can do what, basically.
Yeah, that's really cool. It's really useful to be able to customize it like that. So that's really useful. Another question then to move on, like the way you sort of organize everything with your folder structure to test on multiple versions, and sort of linking back with the file packages to be able to run them and test them in different versions of Unity. But it still feels like you then have to run, I don't know, 5 or 6 different versions of Unity to test it. So it still feels like quite a manual process. Is it manual, or is there anything else you could do to automate that?
Yeah, this is one of the slides I actually didn't get to here on. Like, there's many I didn't get to, but one is automation. So basically, at Needle, we're always trying to add automation as another layer on top of something that you could also do manually. And so, like, I find this is super useful to be able to test things locally and not just like, hey, dear server, here's my new version. Please tell me if there's any errors. You want to be able to replicate things locally. So what I showed you basically is the setup and structure and how you can do that manually, which is great if you're actually developing a package. Like, you're doing changes on something that needs to work across 7 different Unity versions and URP versions. And so the speed of this is just the fastest you can get. Like, you're tapping into another Unity instance and you see if that code you just wrote works in 2019, 2020, 2021. Of course, if your package is in a more stable shape and you're doing mostly bug fixes, this is a good time to automate this. And while not public, we have a couple of in-house tools to basically run Unity's unit tests across these projects. So basically, the idea is, you have this structure, you have your 7 different Unity projects, and we're just running the tests in them automatically as you're making commits, basically.
Okay, that's cool. We were. I was just about to ask about the unit testing. Somebody earlier in the day mentioned that they use the unit testing framework, but by abstracting away from some of the Unity integration there. So the more business logic focused things are, the easier it is to test. So are you still testing packages in that sort of style? So you can test your business logic of your packages easily.
Yeah, so we're mostly using Unity's infrastructure for unit tests. So and there's actually there's two, like there's the integration for the test runner, and there's an entire suite for graphics tests. Like there's a graphics test framework that you can use as well if your packages are more graphics heavy. And so basically what we're doing in our automation is in your projects, all the tests that you have set up are run as part of automation in Unity's regular system. Oh, and again, that means you can do it manually. Like something fails, that's no problem. You open that Unity project on your local machine, you run the tests manually, and everything is just a click away, basically, on reproducing what you saw as a test result. And I like that much more than what I've seen, like especially some large companies have been adopting an approach of kind of fire and forget, right? You're doing your change, you're pushing that somewhere, and then 2 hours later, you get the results on, oh, okay, now everything is red. And so I think that's not a great approach for like stable development of stuff. And so we are more in this camp of you should be able to replicate it locally, but you can add automation on top.
Yeah, cool. That sounds great. Last question then. I think any chance that again, this one's from the chat. Any chance these tools have given you behind the scenes insight into the internal tooling, sort of that's gaining momentum inside Unity? And I think question is really, are they really adopting visual scripting and Bolt or shader graph and VFX graph and so on?
You mean,
is there any indication from what you've seen there?
I mean, what do you mean with adopting these tools? Like they all in active production, right?
I guess that if you're seeing all these packages, I mean, quite often people consume these packages without really looking into them. You're obviously a bit more hands-on with the packages there. So do you know if some of they're picking up more dependencies, and the visual scripting, the Bolt, the shader graph and VFX graph are starting to get more used in some of these packages?
Yeah, so I don't know much about the visual scripting side. Like I have used it a couple of times, but then not for a while because it wasn't in a great shape back then, and I haven't picked it up again. But for shader graph and VFX graph, it's always interesting to look at kind of what mirror logs in terms of what changes have been done, what progress is forward. I think what's always interesting to see is if there's unexpected bug fixes in patch releases, like URP 10.11 or something like this, and then you suddenly have a couple thousand lines of changes on fixing a particular problem. And these kinds of insights are super helpful because they often uncover like problems that have been there. They give more reasoning on should I update my project or not, which is something that I find particularly hard with kind of the opaqueness of how Unity approaches packages on this. Here's a new version. So we're not really telling you why that is there and so on. So yes, I think there's lots of momentum around like shader graph and the SRPs in general on getting that more streamlined. One unfortunate thing I think is that some of the SRP development has moved back to being core packages. So that means they're not on the registry anymore. They're shipping with the core. We can still track changes between them, but it's not as easy anymore to update in the same Unity project between different URP versions, for example.
Right.
And yeah, and we actually fought quite a bit for getting versions back into these packages that now ship with core. Like there was a time when Unity started shipping everything as 12.00, next version 12.00, and so on. And this is, of course, and they said that makes sense because it's shipping in core. But it's impossible if you're actually doing modifications to see that something has changed and so on. So
yeah. To track it. Yeah. Okay. Well, thank you very much for a fantastic presentation there. Lots of really useful information and tooling. So thank you. I think Anastasia.
Yeah, thank you, Felix. That was great. We really enjoyed the talk. So, and we're now moving forward. So, see you later, Felix.
Yeah.
Bye.
Thank you.
Yeah, and before we are coming to our last talk for today and for the last talk of our event, we wanted also to run a very short last raffle for the day. So you still have a chance to win a license for .ultimate. So Alex, unmute and read the question.
Alrighty then. So the first one, a must question from the IDE developers is, what IDE did ID Software use for making Wolfenstein 3D? And I would imagine it's a pretty hard question, so I would give you an options, or maybe someone will give me a right answer while I'm reading those. So option number one, the John Carmack go full commando and didn't use any IDE at all and was just writing directly all assembly and binary code and starting the game. Or he was using, god dang it, all right, so make it a little harder. Which version exactly? Born in C++, because Bo is ahead of its curve.
Yeah, that's great. I think we have an answer. That's
I'm
great.
just kidding, Bo. You
We
are
have
correct.
a
The Born
winner.
in C++ was the correct answer. All right.
Yeah,
So,
that's
and
great.
another question would be close, but it was 3.1, but it's extremely close. But I mean, who cares?
Yeah, we're not going to disqualify them for that.
Yeah. No, not for you. And another one, on what game did ID Software start using version control?
Oh, let it be tough. For the last
just
question of the
think
day.
about it. Just think about it. There were projects that they haven't used it at all.
That was what immediately hit me, and that's scary. It's just the
Yeah.
idea of not using version control.
What would you give up easily, version control or IDE?
IDE, straight in there. I mean, I'm a Vim user. I don't need an IDE.
Oh,
Well, I mean, I work for JetBrains, so I do need an IDE. An IDE with Vim. Now we're talking.
Oh, I think we have a correct answer.
right.
Yeah. Yeah.
Wait.
Quake.
Okay, I'm not slipping this one. I need a correct answer specifically because Quake 3 is extremely close one, but there was a specific, it is still a different game.
Oh, yes.
Okay, Bo, just stop it. I'm not giving you another license.
I think we should count, like Bo already got a license, so I think we should count the next one probably. It was the same timestamp.
The answer was from Ursu, the Quake 3 Arena.
Yeah, congrats. So a little bit later in the chat, I'll throw you an email you could write, and I'll share the license with you. So congrats, you'll get a .ultimate license for your personal use. And now, so we're end up with all the quizzes, and we are running into our next talk. And so here is Ben. Hello, Ben.
Hello.
Good to see you.
Hello.
How are you today?
Yeah, you too. I'm good. I'm great. How are you?
Good. And I'm asking every speaker, and my co-host also asking our speakers the same question, and we want you to answer it as well. So what was the first game you created?
The first game I created was probably typing something out from one of the old Atari magazines. You used to get printouts of code in paper form. And so you were literally just copy pasting by hand. And it was like a move the boat along a canal kind of game. Game in a very loose sense, but literally just like typing stuff out. So yeah, even so many years later now I'm copy pasting from Stack Overflow, but originally it was from paper. So there you go.
Yeah, I can relate, but mine's a bit older with the BBC, and the Spectrum is copying and typing out lots and lots of code.
Okay.
By the way, Ben, I don't know how long have you been awake, but have you heard one of the questions from the raffle? Like OG version of Unreal Editor 1, which UI framework it used to make the UI?
Slate? Probably not. It's probably before then.
No.
So
I think it came like in the 3rd edition of Unreal, but the very first Unreal Editor was made with Visual Basic.
Oh wow. Okay, I didn't know that. History is not as good as wow.
Yeah, that was a great question. Actually, yeah, so we're gonna talk about UI and C++, which sometimes make me like, wow, what do you actually use to do UI and C++? Because many people, if they answer something, they usually say maybe cute, like that they all that's all they know. Hopefully, like in game development, we have more options. So let's discuss how we can do UI and C++. So Ben, the stage is yours. So please
Great.
start.
Thanks very much. Yeah. So today we're going to be talking about UI, how to make UI with using C++. And so, yeah, in Unreal, we don't use Qt or Qt. We use something else called Slate and UMG. So today we're going to be talking about that. And the alternative title for this was how I stopped being terrified of Slate, because Slate in Unreal has a little bit of a reputation of being kind of weird. It looks very odd. It's not really what you're used to in other kind of standard C++ stuff, but hopefully with this, you should be able to look at it and not run away screaming. So before we get there, let's talk about, oh, did it not change? Oh, there we go. Let me click here. There we go. So first, a little bit about who I am. My name is Ben. I'm a UI programmer for I'm a UI programmer at Brace Yourself Games, and I'm working on Industries of Titan previously, and now I'm working on a new project. I've also made a lot of Unreal tutorials that I post on my website at BenUI. So what are we going to talk about today? So first we'll do like a little rough overview of what Unreal's UI tech is. So if you're not super familiar with it, hopefully you should be able to get something out of this talk. And then we're going to make a slate widget from scratch. So just hopefully starting without any boilerplate and explaining what each bit does. We'll do a couple more advanced examples with Slate, and then we'll kind of wrap it up in UMG so it's a bit more modern and user-friendly. And then we'll hopefully have a little bit of time at the end for questions. So Unreal, it's what do we have in there? So Slate and UMG are the main sort of core bits of tech, but what are they? So basically everything in Unreal uses Slate by default. You could use a third party. There are third-party apps that let you make things, the third-party frameworks that let you make things using HTML5 and other things, but Slate is what the editor is built in. So basically all of this you see is written using Slate, and all of this is technically Slate under the hood, and even Fortnite is Slate under the hood. It might be UMG, but we'll see that it is actually Slate under the hood. So what is Slate? Slate is just a C++ library, and it helps make user interfaces easier. So Slate looks like this. This might be what you're used to seeing if you think about Slate, is this kind of odd syntax with open square brackets and pluses. It's a little bit odd, but we'll go into more of that later. It's also got a lot of macros. So this slate underscore declare widget and slate underscore begin args. These are macros that you can use to kind of define your, declare your slate class. Okay, so if that's Slate, what's UMG? So Slate was made way before UMG and Unreal, and UMG and blueprints were a thing. And so it doesn't really know about blueprints. UMG was made to be a layer between, or a bridge between Slate and blueprints. So blueprints can talk to Slate. In practice, that looks something like this. So this is a button, a UMG button. And this, hopefully some of this should look a little bit more familiar than the Slate. So there's the kind of UObject style macros that you might be used to seeing, like uClass and generated body. There's also uProperties, so blueprints can access those. But under the hood, it's actually wrapping a Slate button. So all the widgets you're kind of used to using if you've played with Unreal's UMG system are like, you know, vertical boxes and buttons and images. Those all wrap Slate parallels. And the naming convention is usually identical. So U button is the UMG button, and S button is the Slate button. So U text block wraps S text block. And so if you make your own, generally you want to call it, you know, U something wraps S something. So that's what we're going to be doing today. So that's kind of the overview. So we're going to hopefully, if I go back a slide, we're going to make the S thing first, and then we're going to make the U thing at the end. Okay, so let's start making a slate widget from scratch. The project source for this should be available online already. If it's not, it will be up by the end of the presentation. If you're using Rider, you can create a new widget using the kind of like add class wizard. Just select slate widget and call it something without the S, because it automatically adds the S at the front. So before we get into actually like typing and writing and looking at the code, there's actually a couple of different options of what you can subclass. By default, it will subclass S compound widget, but it's kind of good to know what different classes there are, or like base classes there are in Slate. There's leaf widgets, which don't have any children, so those will be things like images and text blocks. There's panels, which are kind of like very generic, like multi-purpose things like overlays and horizontal boxes that are designed to support kind of up to any number of children. And then there's kind of everything else, which you would probably put in compound widget. So if you're making a new custom widget, you probably want it to be a child of S compound widget. And that includes things like buttons and borders that have one child, or imagine you were creating a new sort of tooltip panel widget that had a title and a body that had like two children. Then you'd probably want to inherit from S compound widget. Okay, so when we've run our wizard, this is what comes out. It's kind of the bare bones of what you can have with a slate widget. We're going to cover more about what these macros kind of become just after, but first we want to get something up on screen. But it's kind of good to kind of note what the base level looks like. So you have slate begin args, the name of our widget class, and then open and close curly braces, which is kind of weird there, and then end args. And then we have a construct function, which isn't virtual or override. So that's kind of odd. Yeah, there we go. Highlight those in the construct function. Okay, and then the CPP for this is, let's go back. The CPP for this is just a construct function. What we're doing here is child slot. Well, we won't go into too deep depth right now, but we will later on. What we're doing here is we're creating a new text block with snew. And then we're going to set the text using like our localized text stuff here. Child slot is like a thing specific to S compound widget. So you can kind of set what the interior of that widget will look like. Okay, and then let's add it to the screen. So I usually put all of my kind of UI, what do you call it? Like overriding the UI central code in HUD subclass. So in this case, my BUI HUD subclass has a shared pointer to this example widget. And we create an instance of that there and add it to the screen using add viewpoint widget content. Yeah. And then, hooray, that's what it looks like when it's actually up on screen. So that's getting a slate widget, like the bare bones of it, from writing it in C++ to adding it to the screen. It's not as painful as it seems, I hope. So let's go back and add some more arguments to our new widget and then look into what the macros are actually doing. So if we add a new argument to our widget, in this case, some text, this means that we could set the text for each instance of our example widget. I guess this could be like, it's a label. We could say this is a special kind of label that maybe we add some extra functionality later. So we add that with slate argument here. What that does is when we create our instance of it, previously we would set text with just a static piece of text, so hello world. Now we have a new member variable within this f arguments called _label text. So it's kind of interesting. When we set it back here, we said, okay, we want an argument of type f text with the name label text. But then here we get f arguments comes in with a member variable underscore label text. And then when we actually create an instance of our sExample widget, we can call a function which has been automatically created for us called label text. So instead of setting the text inside the construct, we're now setting it when we create an instance of our sExample widget. So that seems a bit weird. Let's try and dive into what is actually happening in this macro gunk. I think it helps to understand that it's not complete voodoo. It does do stuff. Let's start with begin args and end args. So it's a macro. It is kind of hard to read like this. So let's clean up that and get rid of all the new lines and so that the text highlighter can actually show us what it is. So all it's doing here is creating a new local struct called farguments with a constructor, an empty constructor, and then end args is literally just like close curly parentheses and semicolon. Okay, so one other thing, we'll just dive slightly deeper. And what is this slate base named args thing? What it's doing is it's defining a bunch of kind of default attributes that every widget has. The tooltip text, is it enabled, what's its visibility. If you've messed around with widgets at all, then you'll see a lot of these things actually exist still in UMG. So the visibility is there, the render opacity. These are things that you've probably seen. Okay, that's probably a little bit too deep for the start, but basically the macros expand from that slate begin args, slate end args to creating a local struct. What about these arguments then? So in our case, we had label text. So in this case, it actually expands to make a local variable within the struct and also a function with the same name. So what we're actually doing here is we're making a local struct called, well, I'll show you in a second, called fargs, and then we're setting, adding some local member variables and setting some functions for that. Okay. Yeah, this is basically just expanding the macros. So you have a local member variable and setting that. So that's why when you use the in-args thing, you can get the member variables. Okay, so we'll go on something a bit more, less about the constructor and a bit more about like some of the features of Slate. So when you are writing a lot of Slate, you'll see a lot of these open and close square brackets and plus. So in this case, what is happening here? So we've got a horizontal box and we're adding a slot, and then we are putting something inside. Like visually, it kind of makes sense, but what's going on? So Slate and UMG, I mean, UMG is based on top of Slate. So if Slate has it, then UMG has it. They have the concept of slots. So a slot is basically a way that containers will control the layout of their children. So if you have a horizontal box, you might want to say these particular parts should fill and these other pieces should only take up the minimum amount of space. Oh, the formatting's a bit messed up there. It basically say, how would you make this? There's a small button, very small button with a small image there. So if you were going to do that in widget using blueprints, you would probably just make a hierarchy like this, where you have a horizontal box, an image, and then a size box that contains a button. And you might say that, oh, I want my size box to be at least 200 pixels wide, and I want the size box to fill the most of the horizontal box, and the image to just take up the size it needs. So that's what it would look like in the hierarchy. So how would we translate that into Slate? So starting off, we have our child slot, just like our previous example. That's kind of like our base, our root widget that we start with. First, we would create a horizontal box, which is kind of what we saw in the hierarchy. Then we're adding a new slot, so it's like a new container to put something. We're going to customize it so it only takes up the amount of space required. That's auto width, and we'll set the padding to something small. Then inside there, we create a new widget. That's new. Then our second slot, we wanted to fill the entire remaining space and have a bigger padding. Within there, we put a box with minimum size, and within there, we put a button. So breaking it down, it's not too painful, I hope. And then it creates that. Okay, so now let's have another example where we want to build a widget iteratively. So in this case, imagine you wanted a big list of buttons. So previously, we've done everything in a kind of a declarative style where we just write out everything our widget will contain. But how would we be able to have a variable number of buttons? So we can't do snew depending on the number of buttons in this style. So what we can do is we can use assign new and save a pointer to the vertical box that we want to add the buttons to. So this is the syntax for it. You would have a tshared pointer to the thing you want to keep, and then assign new as the variable first, and then the variable type. So coming up with another minimalish example, we have our shared pointer to a list box. We've also got some arguments there for the number of buttons, but that's kind of the same as our previous examples. So in here, when we create our widget, the first thing we do is we save out the vertical box to a variable, this box. And then we're going to rebuild from data every time that the number changes. So every time that we change the number of buttons we need, we'll refill the list box. So we clear the children and then iteratively go through calling add slot. So add slot is kind of like the same thing when you call plus in your declarative style. This one is in a more iterative style. And so yeah, that's what you end up with at the end. So that's enough slate for now. Let's see how we can wrap the slate with UMG. The reason you would want to do this is because, well, UMG is a bridge between slate and blueprints. So if you ever want blueprints to be able to control the slate, or you want to be able to kind of edit the variables from within the editor, you're going to need to create a UMG wrapper for your slate widget. So this is back to our original example of just a text, a widget that has a text label. So the base kind of, what do you call it, minimal widget, UMG widget is this. The main thing you care about in this case is rebuild widget. So if you notice here, we do have a shared pointer to our example widget. And we do have like a local copy of the text we want to set in there. So when that gets changed, we will rebuild the widget, which is kind of like creating the slate widget again from scratch and setting its variables. So this is what the body of the function would look like. When you rebuild it, you just create a widget using snew and set its text using label text. So that's that function that was created when we added the slate attribute to our kind of constructor. And you have to make sure to also release the slate resources, otherwise you get a crash. So now to actually see it in game, you can add it to the screen just as a vanilla UMG widget, but it also means that we can add it to user widget blueprints, which is kind of like my preferred methodology for this. So it's listed in our uncategorized palette on the left near the top. We can drag and drop it into our widget. So you see example widget there. And then when you select it, there's example text shown in the top right. And that's just the U property that we put there. If we wanted to change every time we edit the sample text, instead of having to hit compile every time, then we could override synchronize properties to do that. If you look in the example on the GitHub, then you should be able to see how to do that. Oh yeah, so here's the C++ for how to spawn that user widget blueprint. So I like putting everything in HUD subclass. So here you would have a soft class pointer to the user widget. You could just do a T subclass of, but then you're kind of like, you're going to end up loading the blueprint itself every time your HUD gets loaded. And then you just call create widget and add it to viewport. This is kind of like a more of a standard workflow for creating blueprint user widgets. So you might be more used to this. Okay, so that's kind of the general overview of how you make a slate widget with some more complicated ones, and then wrap it in UMG so you can show it on screen. Just for like a final little bit of more discussion on like when would you want to do each one? So why would you want to use Slate? Why would you want to use UMG? Why would you want to use user widgets? So user widgets on their own, you would probably want to use those most of the time. I do most of my work using that. It lets you create the layout using a visual editor, which is a lot more natural for a lot of people. If you're just using a bunch of standard widgets, then there's no need to create anything from Slate necessarily. You could create, if you're working with editor code, then you would need to move into Slate. But you would probably just be using standard widgets for that. So if you're doing game dev, and the reason you would go into Slate and create a new custom widget is if the standard widgets don't have the features that you need. So those might be for performance reasons, or for if you're doing some really complicated layout. I could imagine that's why you might want to do it. But a lot of the time you can kind of get everything you need out of user widgets. It's just for editor stuff and for performance that you jump down into Slate. For more references on how to create custom Slate widgets, then I'd check out the Lyra Starter Game project. Your Lighthouse has a really amazing Slate compendium, which is just a huge document full of all the information you would need about UMG and Slate. And Alessa has some really good Slate resources as well, like a list of editor plugins with really good examples. I think the best way to learn this stuff is to look at examples. So dig into the editor, see how they've implemented stuff. You can use the widget reflector to select widgets and then see how they're declared in C++. So yeah, thanks for listening. That's pretty much it. We should have time for questions at the end if anybody has any questions.
Yeah, thank you, Ben. Thank you. That was actually a great talk, and I enjoyed it a lot, even though I was really a little bit confused because I was sitting and thinking about, oh, I see macros again. Okay, so we're in C++. Unreal Engine is macros. Slate is macros. So what's going on there in the world? Can we use something
always
better?
with macros?
Yep.
Yeah, but I mean, seriously, do you know if there is any opportunity for us to do better?
It's what everything is built on. It's the stuff that everything is on in Unreal. I don't know if that will ever go away.
Macros in the essence of everything. Unfortunately or fortunately, I don't know. Okay.
Give me two cents about the macro thingy, and I'm pissed that I'm not getting into the Unreal C++ talk, being Unreal dude in the JetBrains. All right. So currently, with the introduction of the data-plane arguments, I've seen in the last versions of Unreal, they are slowly migrating from some macros to C++. So, for example, for declared delegates, as well as there's proper C++ implementation that looks much nicer even than the macros itself. And I mean, that's much nicer to use one. I don't know for myself if there's any plans to add it to Slate, because I'm not sure that the macros in the Slate are more for the Unreal header tool, or they are actual C++ macros that actually evaluate to something. I need to dig that up for myself.
I don't know myself. Yeah, from what I see, it does seem like they're just regular macros, but again, I'm still relatively new to this stuff, I guess. Yeah.
So I was going to ask us, the example you gave at the start was Fortnite as using its UI, and obviously the UI there is heavily custom. Can you go from what you've shown into those custom UIs?
Yeah.
And how does that work?
I have an example. So if I go back to the start, can I click here? Nope. Okay, let me go all the way back to the start. Okay, everything's Slate. Yeah. So I think in this case, you would probably want to be using Slate for performance reasons more than custom layout. But a lot of this, you could technically do it all in blueprints right now. Like all of the kind of pop-out boxes with the exclamation marks, all of this could really be done. If you had some very complicated layering stuff, you would probably want to do that in materials. So to be honest, Slate is mostly used for editor things. I've seen people use it for kind of mini maps and custom stuff like that, where things are not necessarily, perfectly on a grid or aligned, and you have lots of widgets kind of moving around. I'd probably use it for that. And then also, it's just for performance reasons. Like if you're spawning a particular widget, hundreds and hundreds of times, if you can avoid using UObjects for that, and you can go straight into Slate and just do it that way, that you're saving a huge amount of overhead on memory and spinning things up. If you've already tried using like pooling widgets and other solutions, probably I'd do that first. And then if that's still too much overhead, or you're targeting a particularly resource poor platform, then maybe you'd want to start doing things in Slate.
Okay, so because I'm not familiar with the with Slate in this way at all, what would be the widgets on that screen there then, or have I got that wrong?
No, yeah, these. You could probably guess some of these. This. I don't know if you can see my mouse, but across the top here, that could be just a horizontal box with a bunch of buttons inside.
Okay.
I can probably speak better to my own UI rather than saying all the wrong stuff about Fortnite, because
Sure.
I'm sure the actual developers will be like, no, that's not how we did it at all. In my case, like across the top here, when you've got those speed indicators right at the top, that's just a horizontal box with 4 buttons in it. And the buttons have a state for like, are they selected or not? On the left here, it's that's just an overlay, and then inside there, it's a lot of overlays within overlays with padding and stuff. Maybe you've got a scroll box and a bunch of text elements, like rich text elements, so we can format parts within there. So like these kind of where it says employees there, you can tooltip over that and show things. Let's see. You end up with sort of fancy things like drag and drop elements down here that you could drag and drop these. I'm trying to think what other stuff there is there. Most of it is just buttons and horizontal boxes and vertical boxes. I try and use those over canvases. Canvases let you kind of set the positioning more specifically, but a lot of the time I do okay with just overlays and horizontal boxes and padding and stuff.
Mm-hmm.
Yeah.
Would you say then this is better suited to a more sort of head-up display kind of UI?
You could. If you weren't going for something super complicated and you were making something that's a bit more static without huge amounts of kind of changing data, then yeah, Slate would probably work well for that. You would probably minimize some of your overhead a little bit, but again, it would slow down iteration time. It stops if you write everything in Slate, then artists or UI designers can't come in and move things around easily. They were forced to talk to a UI programmer to mess with stuff in C++. That's why I guess that's why UMG was made. Like UMG and blueprints, it lets less. Yeah, it doesn't. You don't bottleneck by programmers.
I guess there was some question about learning resources. So do you have some in-depth resources to learn Slate, not by widgets, but in the custom details panel scope?
I don't have as much with that, but let me go to the end here. If you wanted to do custom detail stuff, Ellis's Slate resources are very good for that. You can look at some of the links from there. So I'd recommend checking those out. There's also, you can ask questions on the Discord. Like I have a Discord that people talk about UI stuff specifically. Otherwise, yeah, those are those places I would start. My website has some stuff, but I haven't done stuff specifically about editors as much as like Alessa and others.
Mm-hmm. Okay, thank you. Yeah, and I want just to share with everyone that we'll definitely try to share all the slides and all the useful links from all the speakers later. So we'll put them in the description of the individual videos and in some follow-up. So yeah, be sure we'll do that.
There's one more question from the audience, from the Retail. Is double checking do slate we just hold hard reference to the UMG ones that rep them?
As far as I know, they're not. It's not bidirectional like that. Usually, it's kind of tricky to go from slate up to UMG. Like UMG kind of owns the slate instance. There are some times where I've definitely wanted to do that myself, of go back up to UMG and poke stuff that way, but I don't think so. I think there's some hacky ways to do it, but no, I don't think so.
Okay, thank you. So I would like to thank Ben for the great and colorful talk here. That was really cool and really very, very interesting. So thank you, Ben, and hope to see you at some other events. Yeah, thank you.
Have a great one. See ya. Bye.
See you. Bye-bye.
Yeah, and we're actually wrapping up. That's it for today, and that's it for our Game Dev Day. So, and I think, wow, it was such a great day, like game-based presentations, interview, unexpected live demo. Thank you, Matt. Ruffles, Unity packages, performance topics, and finally the UI. So I think, you know what? Mission accomplished. We did that. So first ever game development day online by JetBrains is now over. And it was a great long day with incredible talks. So this link will stay, so you can still rewatch all the sessions by this YouTube link. Later, we'll cut it into individual videos with some description and useful links. So if you register for the event, you'll get like some useful links to that. And also we'll send you a survey. So please do fill it out, as we really need to know how we can improve next year. And I think definitely would like to run this event once again. So see you all next year. It would be great. And thank you all the speakers. Thank you, fantastic crew. And thank you, my co-hosts.
Yay, co-hosts are the best.
Yeah. And I think then with that, bye everyone. Thank you.
Thanks, everyone.
Thanks. Bye.